And real quick, a couple of things that we were talking about yesterday as we're going through some of this is how when you create a surface, when you model a surface, what the computer is going to do is look at all of our data, and it needs essentially X, Y, and Z location information for every point that becomes a corner of a triangle. And all of these triangles then are all stitched together edge to edge, and they form basically a blanket that lies over the shape of that surface. And those points can come from a number of different locations. You can even, like what's shown here, you can even read in a file, a data file. This actually came from a USGS quad sheet that was DEM data, digital elevation model data, that's every 30 meters. If you see the meter count on the coordinate and the Y's over here, it jumps every 30 meters. So that's a 30-meter grid and the elevation for each of those points. Now, that's perfectly legitimate. That's just as legitimate as it is to read information that looks like this, which are a bunch of points and three-dimensional lines that become break lines. And we talked about how break lines serve the function of preventing points on one side from looking across to the other side to find other points to connect to. So if there's a break line or a barrier in the way, then it can't form those potentially erroneous erroneous triangles. And sometimes the triangles that form are legitimate, but sometimes they're not. So we need to make sure that our data is well conditioned. And here's one of the things that we like to do is to make sure that the data we have is sitting at the right elevation, sitting at its proper, or at least a proper elevation. Otherwise, and you'll see this a lot of times when you're looking down at something like this in plan view, see there's this road across the top and this little driveway that comes down the edge. And that is this feature right here. The road goes across the top. There's another side road over here, and this little driveway that comes over, and a house site, and a stream bed that comes down the creek. So what you'll see sometimes, though, when people build these maps and send these to you for a source, is that they'll have maybe, this stuff elevated, but they won't have the roads at, the edges of the roads that you want to use as break lines. Maybe they're all compiled down at 0. Same thing for the stream center line. So it could look like this, and you just need to verify before you model your data that things are what you're expecting. And the easiest and quickest way to do that is to just load stuff up in the 3D viewer and look at it. And if it doesn't show up because we're saying, ignore 0, or we can look at things like that color spectrum to see if we've got something that's, some extreme outlier value on elevation. We need to somehow take a look and verify our data. And so there's a number of tools that we're going to use to do that. The most useful, the one we use most of the time, is our 3D viewer. And you can do that either with Carlson's viewer, which I like a lot, it has a lot of tools in it, or you can just use the CAD 3D views, but then you're constantly having to set your view back to plan view and move yourself around, all of that. So we're going to go over how to use the viewer, and then also talk about a couple of other tools that we have to evaluate, what's happening with our data. Okay, so let's, with that, jump back in and go ahead and open up Carlson, and we're going to load up that sample from T3 Global again. I think could be some of the others we could use, but that'll be fine.
Is it okay just to use, because I did not close mine yesterday. Is it okay just to go ahead and use that so far?
To go back to the beginning?
No. I didn't close the project when we started it yesterday.
Oh, yeah. If you still have it up and running, you mean? Is that okay? Yeah.
Okay.
Yes. Yep. So let me see what we've got in here. Yeah, let's use that sample from T3 Global just to show you how we can use this and use some of the tools, because this is pretty dense bunch of data, and it's going to give us some means of verifying what we have. So we've got our information in from, say, a subcontractor that has prepared this as our base mapping, and we're going to either, build this for a construction project. Maybe this is the design that they gave us, and this is the existing ground. We're going to model this, and then we're going to model the design ground on top of or below that, and use that to compute, help what our volumes might be and that sort of thing, for cost estimates, and also to create our models and put them on our machine control equipment. So we have this. We want to start taking a look at it. Here's some of the tools that we can use. Let's first of all go to view, and we're going to freeze layer by pick. It's about a third of the way down at the bottom section of that menu. And we're going to pick one of those white lines so that our brake lines are turned off. And we've got basically this nice information. We look at it and we see those nice sharp contours, and we might be very tempted to say, oh boy, got everything I need. I'm just going to jump in here and use these contours and build a terrain model. Because I see, well, look, they've drawn all of these curves and such in there for me. And if I look at that, if I look at the shape of that contour line, see, it comes over here and it hits into that face of the curve there, and it climbs up, wraps around, and comes out at the top over here. So it appears to be behaving correctly. So that might tempt you into thinking that these two lines are sitting at three-dimensional, sitting at their proper elevations like they would be in space. But if I look at them, select them and look at them, look over into the properties, I see that they are just polylines. They're two-dimensional polylines, and they have an elevation of 0. 2D polylines can be used because this is also a 2D poly, but it has a specific elevation. There's 1313. Okay. So we might look at this in plan view, and we'll see things like that, and we might be tempted to think that, oh, well, see here, the contour wraps around like it's supposed to, so these must be 3D edges, and we'll just use them and go right along. But like I just showed you, we may find out that there's 0. So how do we find things like that out? How do we check and see if things are at 0 elevation or not? And there's a number of techniques. So we're going to look at a few of those. The first thing I want to show you is to look at the inquiry menu and go down to this drawing inspector on and off. Okay, so when you choose that, it's either going to turn it off if you had it on, or it's going to turn it on if you had it off. Look down on the command line, the line above, it says on mine now, inspector on. right click to activate pop-up menu. Well, so if I right click the mouse, these are the things that I can display. And when I mean display, they're going to pop up when I hover the mouse over top of anything in my drawing. So let's look at, well, like I've got shown here, display the layer name and the elevation. So if I click off of it, and notice the only way that you know that the inspector is on is like this. If you look on the inquiry menu, well, they used to, it looks like they've changed it. They used to, the icon would change and look like it was pressed in, but it doesn't show up at all there. Same thing, this point object used to show up, so that might be an interface change that they made. All right, but the other indicator is that the cursor is no longer just a crosshair. It's a crosshair combined with a little mouse pointer arrow. And in fact, they'll separate a little bit. One keeps chasing to catch up. But you can also just simply right click, and if you get this menu, then it's running, and you can choose to turn off the drawing inspector with this choice, or go back to inquiry and choose the drawing inspector on off again. That will turn it off. Okay, so right now, if we hover the mouse and I look at that curve line, I see, well, I see what layer it's on. That's good, but it's got an elevation of 0. When I go over here to the contour line, and I'm not clicking anything, I'm just hovering. So I see it has this constant elevation. So I may look at that and say, let me look at this road edge, this parking lot edge, and I see, well, V parking outline. I get the layer, I can understand that, but I see that the elevation is not showing up. It's all 2D lines. So, where might I be able to find that information? Or in the case of like this, if this is all they gave you and you wanted to use those as 3D break lines, well, you have to give these some elevation. And the only place they get elevation information, at least from what you're seeing, are from these contour lines that they cross. Okay, so you can do that, and it will come in here, and as it hit that contour line, it would set that elevation to 1314 at that point along that feature. Okay, now this would be a little odd. We need a bit more information, because when it sets that point to 1314, it then travels to every vertex along that looking for other intersecting 3D lines. It won't find anything until it gets back around onto itself again and sets that at 1314. So what winds up happening is that it sets this base at 1314 all the way around it, which is not exactly the true condition. Because if you look right here, 1314 is up here on this top line as well, which means this point right opposite it, down here on the face of that curb island, is 1313.5. See, it's 6 inches lower than that. So if I were to do this properly, I would say turn that into a 3D polyline by reading where it crosses those elevations. So 1314 there, 1314 there. And then I would go to my editor and I would find the point right opposite that point and make that 1313.5. And so then it would go to this point, make it 1314, drive all the way down to here, make it 1315, and then climb back up to 1314 over here. And now, again, with nothing else here, it would just keep that at 1314 all the way around. But in reality, you got a situation like this. You've got, at least according to what we see with the contours, the elevation of this point right here should be somewhere between 1314 And 1315 should be something like 14.25 or 3 or 2, whatever that proportion is, assuming that climbs up there proportionally. Okay. So there's a lot of work that you have to do to start to elevate things if you don't know any further information. But the first key is to try to find out what you have. Okay, so you can use things like this drawing inspector. Now, let's go back to the view menu and choose fall/on all layers. And now come along one of those edges that you see, the white ones. Now we go back to our curve island. And as you hover the mouse, look at the elevations. And it's a continuous change that it reads. So there's 1314 right there where that contour line hits it. I trace it around here. I see it consistently getting smaller till I get around here. It's going to be 13.5. There it is. Comes back up, climbs back up to 1314 to here. And then as I go around the edges up here, you see it's 13. It actually goes from 1314.0 and then it climbs up here to 1314. See, it got up to something 1314, almost to 1314.4. And then it starts to tick back down toward 1314 again. So 0.36. So you can see as you're looking at things like that, and you look at things like this, which is just, it's a line out there on the ground, but it's something that the people that put the data together thought should be put in there as a break line. If I look on these road edges and start to track along here, you're going to see elevations. Okay, so right in here where if you built it from contours, you might have triangles that form straight across. It would be at 1306, but really it should be 1305 and a half right in there. Okay, so you're halfway in between those contours. All right, so that's one way to do it, is with that drawing inspector, or yes, the drawing inspector on the inquiry menu. And I'm going to now go back and choose that and choose that command again to turn it off. And it says right down on my status bar above the command line that the inspector is off, just to get it out of the way. It can run while you're doing everything else, but it sometimes can interfere as you're moving your mouse around. You have everything flashing up on the screen. So it's meant to be turned on and off. So that's a means. Okay. There's other means like, and we'll use this tool a little bit more later, but go to the.
So Ken, I have a question?
Okay.
So for that, for those elements that are like at the 0 elevation, can you just so changing the elevation to whatever it crosses, whenever to what value it crosses that the polyline?
Yeah.
The contour lines, it makes it converts it to a 3D, right?
That's correct.
Okay.
If you have this, then it's 2D. Of course, now here's something else to keep in mind. This contour line, it's also a 2D polyline, but it has a non-zero elevation. Okay, so that's perfectly fine. It's just sitting at a constant elevation all the way along, so it's still 2D. But as soon as one of these vertices has a different elevation than the others, then it becomes a 3D polyline. Okay. So if we were to convert this, well, that one's 3D because I turned the brake lines back on. So if the line that's underneath it, let's index the background here. If I look at this guy, and I see in my properties, it's a 2D, it's just a polyline, 2D polyline at 0 elevation. So I could start assigning elevations along here where it intersects. Now I need to do that with certain tools. I can do it, by stepping through these vertices. But see, there's no vertex right exactly where that intersects.
Yep.
Okay, I would have to create one there, and I have to do some tools. So we've got some tools that will do that. And they're mostly on our 3D data menu. That's where we're going to be able to turn 2D elements into 3D elements with this command right here, for this menu choice. And you can do it by surface model. So if you already have a surface model and you want to draw something on that, let's say I had this already modeled as a surface, but I needed to put in a water line. Okay. And I wanted to keep it a constant 4 feet beneath the surface. Well, I would just draw in a 2D polyline right where my pipe's going to go. And then I would say, turn that into a 3D polyline by the surface model so that it goes and reads the elevation of the triangles at every point along that surface, along the pathway of that line, just like cutting a profile for it, right? And it sets it to that elevation and turns that into a 3D polyline. At which point you could either move it down 4 feet to get it below frost zone, or, whatever it happens to be in your area. Or you can even do that all in the same operation. You can give it additional plus or minus things. You could draw a curb on say a newly graded area, and you're going to, put a curb island on a parking lot. Well, you would just draw the thing in 2D and then say 2D to 3D polyline by surface model so that it reads the surface file and gets its information from that. But the most common one we're going to use is this by screen entities. And that means anything that it intersects that has elevation, it will read the elevation at that intersection point and create a vertex at that point. It can also do it by points. It can do it some of these a little more complex methods like a slope or reference. So you can have, say, the edge of a parking lot that runs alongside the edge of a building. Maybe the building has a particular elevation along its length. Maybe it's not a constant elevation. Maybe it's a sloped line. And you want your parking lot to always be a continuous 3% slope down from that building or some such like that. So it can read the elevations along a chosen reference line and set its elevations relative to that reference, up or down, or keep the same, whatever. You do it by a drawn profile. You can even do it by text, and it will go through and read the text to set the elevation of certain features. Okay. You can do it by text with a leader. Now, if you think about that, if you have, say, a grading plan as part of your files that you have, and you see all of these, top curb, bottom curb, gutter line, spot elevations, and they have leaders drawn pointing to where on that feature those particular elevations are. Well, you can have the system go through and read all of that, and it reads the text that's in the drawing, even though it's only text, and then it sets the elevation of your particular non-elevated line work to that elevation. And you can also simply tell it a start and stop elevation. Let's say it's not a closed structure. Maybe it's a stream bed or something. And, well, it starts here at this elevation. It goes up to that elevation, 200 feet away, and it goes through all these twists and turns, but I want it to just climb at a steady rate. Maybe I'm building a haul road for an ore truck, that I know over here locally in West Virginia, we can't have any roads any steeper than 8%, because they're hauling, heavy loads of coal and mountain overburden, that sort of thing. So we often would, maybe draw the track of a line of a line along the ground the way we want the road to lay out. Maybe we're constrained to have it in a certain place horizontally. And then we say, well, we know how long that line is, and we know that we need to go from this elevation up to some elevation. We don't know where or what, but we want to make that line go up at, say, a constant 8% maximum climb rate. So there's all kinds of these tools that you can do to set these at elevation. Here, this last one, that's a standard AutoCAD one. That just turns a 2D polyline into a 3D polyline without changing its elevation. So I could make those contour lines 3D polys instead of keeping them as 2D polys with elevation. I don't have any particular need to do that, but you have that command and it's on there. Okay. So those are some of the tools that we can use to create that. But for right now, what are we doing to evaluate what we have to make sure things are elevated? So let's take a look at this. I'm going to go back to the view menu, and I'm going to say freeze layer by pick. I'm going to zoom in here. I'm going to pick one of the contour layers and the contour label and the other contour layer. And now you see I've got these dashed green and dashed yellow lines. I'm going to pick one of each of those so that I've turned off my contours. I may as well turn off these pink spot elevations too. So now this would be the raw data that I have. And I might want to evaluate that to make sure everything looks good as to what I have. So what are some other techniques that you can use? Well, you've got a really handy little tool, just a command under the file menu called drawing cleanup. And you don't have to turn off the contours. I just happen to do it, but just so you can see what is a possible situation. Now, there's a number of things here in this command that this command does more than what I'm going to show you here. But this is specifically useful for looking at the elevation content of your drawing. So if everything's on here, you see you can remove duplicates, duplicate lines, duplicate text. You can join up lines that have the same endpoint. So if you have an exploded polyline, you can do all that. Erase any blank text entities that are left over, any hatches, etc. So I'm going to go to the bottom and choose clear to uncheck everything. And then I'm going to go back up to this last box. This says set elevations outside range to 0. I'm going to check that. Okay. Now what this will do and what it's meant to do, we'll see a little bit later, a better example. But right now, to evaluate what we have, if we turn that on, and we don't worry about what these max and min elevations are set to, because we're not going to actually follow through with this. But what we are going to do is choose this button that says scan drawing. So when you do that, it then fills in what it finds for the minimum and maximum elevation. Okay. So let's say it does all that. You're familiar enough with the site that you know that you're around 1,300 feet elevation. But if you hit the scan button and say this max number comes back at 50,000, well, you've got something wrong somewhere. You may not see it in plan view, but if that number comes back, or you get this back as say -3, or something. So you know you've got something that's sitting at an elevation, but it's not at its normally expected elevation, something really deep or really high. Now, we notice it didn't say our minimum was 0, and we have 0 elevation lines in there, and that's because we're telling it to ignore zeros. In fact, just leave you there a second. Let me, well, we can go ahead and close that off. So that just lets you read that. But I'm curious about if I change this, will it have the effect there? I think all that normally does is just set for when you're modeling the surfaces. So let's look at drawing cleanup and scan the drawing. Yeah, it doesn't have an effect there. This scan actually does normally ignore 0. And so you don't have to worry about turning off 0 elevation items. But anyway, so if that comes back as a weird number, when you choose that, say here, drawing, oops, I keep popping off there, there we go. So if that comes back when you scan the drawing and you get a weird number, I know I'm supposed to be around 1300, and yet this comes back at, say, 25, or minus 100, or some, or this number comes up to be 45,000 or something weird like that, that is way outside of the range, and maybe only one of them is. So, but I know I'm somewhere between like 1279, 1280 to 1350. Well, if I know that that's what I'm expecting, I can get these odd numbers, and then I can come in here and say, well, I'm going to say, let's go from 1,000 to say 1,500. Okay, so I'm safely within my 1,300-foot spread is going to be safely within that. And so once you hit scan, you look at these numbers, and then you would change these numbers and give it a range that you'll live with. But anything that's outside of that range, either lower than or higher than, what it's going to do is set their elevations to 0. So it won't erase them, but it will put them at 0 so that they're no longer used to model your surfaces with. So if you were to select them and use them to build your surface, you would get a real high spike or a low spike if it went negative in your surface, and it would be a problem with your surface modeling. So right away, this is something that you can use to evaluate what's there. And if you get bogus numbers down here, go ahead and edit those numbers, make your range acceptable, and hit the OK button and let it fix that for you so you don't use that as a source of error. Okay. So a couple of other things. We looked at the drawing inquiry.
Ken, then, not to interrupt, but so if all of a sudden something was with out of that range, out of that comfort zone, it could be one or multiple things that are triggering that. But how do you then go to uncover the source of that?
Like, well, in a case like this, I would tell it to put those on. I would come here and I would say, put those on, say drawing cleanup, and I would say set the elevations outside of range. I'd scan my drawing, I'd see this goofy range, then I would change this to be something like, well, I want to go from 1,200 to 1,400. Anything outside of that, I want you to change, put it on 0. And so once you scan the drawing, you see those numbers, you change this, because you need to have some knowledge of the site.
And where do you assign layer 0 then to identify
don't-
those.
You don't, it sets the elevation to 0. Okay, now what happens there is when that sets those to 0, it doesn't tell you which ones were offending that rule. It just sets the elevation to 0. Okay. And if you have other things at 0, it's not going to show you what they are. So you would need to do a different technique if you're trying to figure out which ones were the problem. Now, once you've done this for a year or two or 40, you start to recognize things that, oh, hey, that should have been a break line. I know just by looking at what it is, it should have been a break line. I'm sure the surveyors meant for it to be a break line, but they accidentally made it a 2D poly at 0. So now I know that I'm going to need to go and elevate it. But in a case like ours, where we have all of those planimetric features, those road edges and curb lines and islands in the highway, we have that entire set also drawn as 2D. Okay, so one thing you could do up front is if you you could, wow, this gets into a little deeper knowledge than you necessarily need to worry about, but you could do this. I would right click and quick select, and I'm going to look at my entire drawing, look for any entity, so I'm going to say multiple entity types whose well, let me see if I do polylines, whose elevation is equal to 0. And then I would say, okay, so now it's got all of those 0 elevation polylines selected.
I see.
All right, so now with that being done, it's 283 of those, right? So I could then go to view, show hide by selection. I'm going to hide by selection. And it says, okay, select my entities. Well, because I previously had them selected, I'm going to type P for previous and enter. Now, those are all now technically hidden. Okay. And so if I were to then, at that point, go to File, Drawing Cleanup, turn on Set Elevations Outside of Range to 0, scan, it gets some weird numbers. I say 1200, to 1400. And I would change my entities to process to a selection set. And because I've hidden all these other ones that were already at 0, I'll say, okay. And I'm going to come down here and I'm going to do like that, select all my data, and off it's going to go. Now, see, it didn't find any, but all right. And so now with those things selected, I would go back to my quick select and I would find, the same thing here. Now, this is not totally going to work because if you were to look, see, if I say multiple things, elevation is not a choice. So I have to look at that in terms of things that have elevations like a polyline, and then I would find it's wherever I managed to put it. I'm just missing. Oh, I keep changing off of that. Polyline, there we go. Whose elevation is equal to 0. And I would say, okay. Well, actually, it still finds them even though they're
right.
In. All right, so there's
No, I understand. I
so
thought there was
there's various ways that you can do that. Now, there is I'm going to go back to my view menu to my show hide by selection and say show all, so I turn it back on. So there's that, but mostly what I would do in this instance is I would take, I would look at the things that are down at 0 and, see if any of them look like they should have been break lines and figure out how to set those accordingly. There's other techniques, and you can do those with, if you set the, all right, so let me see that, and all right, so I've got 5. We had those 283 features. Those are all the things that were at 0 elevation. So you could do this. You could say, CH prop for change properties. Okay. Select the entities, and again, P for previous. There's those 283 things, and I'll say enter to finish. Now, what am I going to change here that is going to be easy enough to change back? Maybe color. Okay. So what color is it going to be? I'm just going to call it, I think red would work. Yeah, so they're red. So now when I look at this, let me show this in 3D so I don't have to turn things on and off. Just show you too what they look like. Let me not ignore zeros. So you see all of those things, with the exception of things like these text labels and the blocks, which wouldn't have been considered anyway. I just did polylines, but I turned them all red. Okay. So then if I were to go back and say, drawing cleanup and set elevations outside of range and add some goofy numbers, and I said, well, okay, outside 1200 to 1400. If it's outside of that range, except of course the ones that are already at 0, it won't bother them. Then any of these other things, I'm going to say, go ahead and select those and set them to 0. So as it goes through and finds that out, now you've got another set of entities that are at 0 elevation. Okay, but they are not red. They're still whatever their color was. Now, if their color originally happened to be red, well, that's a different story. But so now you've got a couple of different properties you can look at. We want to be able to select, let's see, let's do this. If we did a quick select and we want to look at those polylines with an elevation equal to 0, and instead of include in a new selection set, or down here to list these, you could say append to the current selection set, because you couldn't have selected you would uncheck those, and then maybe here's let's do this. Elevation equals 0. I said I'm going to 283 again. Okay. And now I think, yeah, see, those are all selected over here, still in my properties. So now I have a selection set active. So I'm going to run this quick select again, and I'm going to apply this to my current selection. And I'm going to say this whose color is not equal to red. And I'm going to include that in a new selection set. Boom. And it's going to go off and find the ones that just got changed to 0 elevation, ignoring the ones that I temporarily turned red. Okay, so there's a number of techniques that you can use to isolate those things that got changed. But the biggest thing that you're going to get from that is simply the fact that it will tell you whether you got something bad or not. If you get expected values, then there's no need to go any further, okay? So I'm gonna select everything in my drawing. I'm just gonna change its color to be bilayer, which is what they were to start with. Okay. All right, so now I'm back to where we were there. We looked at those techniques. Here's another couple of techniques that you can look at as well. On your profile menu, you have this tool at the very top called Quick Profile. And you can use this to just basically cut a section across your drawing, or technically to cut a profile, but you'll hear people call it cutting a section. And you can choose from one of 3 different sources of information: screen entities, or a 3-dimensional polyline. So it would actually walk that 3D polyline. So let's choose that, for instance, and choose OK. And then let's select a 3D polyline that we want to profile. Well, let's see one that would be good. Let's just take this one that goes down one of these road edges. Any one of those, just pick that line. So now, once you pick it, you're going to get your screen splitting into 2 views. There's the top part, and then there's the profile part in the bottom. And as you just hover the mouse and track it in the bottom, you're going to see where that is, and you're going to see up in the top a little marker that walks along that line, and you see that it reads over here on the right over here. You see it reads what that slope is, what station is, what the length along that line is, and what its elevation is. Okay, now you can do things like come up here and zoom in and pan this around using the wheel on your mouse, just like you normally would. Okay, and then you can come down here, and if you need to see, here it is with a one-to-one vertical exaggeration. So that's the actual slope out there on that ground. But if you needed to see it steeper for any particular reason, if you need to exaggerate it, just so you can see the changes, then that's going to be what happens. All right. You can even, save that as a profile file, or you can draw it as a profile, just like we looked at yesterday, drawing those profiles of those road profiles. All right. So that's using a 3D polyline. All right. So that's something that's sort of like using that drawing inspector with the elevation on, and then hovering the mouse and just noticing what those values are. But you can't see it. You're just getting the numbers in that case. Here, you can see it. You can't really interact with it. You can zoom in and out and, verify stuff. And you'll read things over here as you pass along it, but that's fine. Okay. So let's choose exit to come out of that, and then run the command again. Quick profile. Remember, it's the first one on the profile menu. Now this time, let's choose screen entities. And let's uncheck this ignore zero elevation. And let's say okay. And let's just strike a line across that main entrance road. So I picked a point on one side, came across sort of perpendicularly, picked another point, and now it's looking for more points. I can keep going and choose my line of profile, but I'm finished with what I need. So I just hit enter. And now I get that same business. And you see, if I'm over here, I'm coming down, and everywhere it crosses some feature. So I'm going to get right to here. Right in there, right there. And then it's going to jump way down here to the zero, because up in here, you see what it did is it came up here, cross that as a 3D line. So I know that that's got elevation, and then it dropped right here very suddenly. It dropped down to 0, and then it climbs back up to this elevated line, and then goes over to the next one. Let me get this to reset it. So now there it is at no vertical exaggeration. So you can see what a difference. So I've got some things up there at the proper elevation. You see the shape of it, but they're dropping down and hitting 0. So let's say if you have you know, something that's down here that's not 0 necessarily, okay, but it could be like, you know, minus 0.1 or sitting at 100 when you're up here at 1300. So you would see that because you wouldn't be expecting this kind of thing to happen. All right. And now let's exit that again and run that command one more time. And this time keep it as screen entities, but check the box that says ignore 0 elevation. And now you're going to be able to, let's do a little click across like that. And now you can see a bit more of the shape of the data that you're crossing. But keep in mind, when you cross that data, now here's a case here in this right in here. And again, I'm just using the wheel on my mouse to do this zooming around. So I'm coming over here to my road. I'm hitting right there, and then it jumps up and it hits that next line, which is actually the edge of a curb. And then runs across here, it hits the back edge of the sidewalk, and then it starts to climb up the hill. And because it goes up to this hill, to this flat cemetery, which is, you know, when it comes up here to the top and now it goes across here, there's a flat cemetery up there. Okay. So that helps you to maybe verify some of these things, and you can tell if there's a problem with them. Let's exit that. I'm going to run it one more time. Same deal. And we'll maybe come up here and look at these curb lines. Let me see what might be. Let's go across like that. So now when I'm looking up at this, I see, yeah, okay, that looks like that might be. I've got a little crown right there where you see where my crosshair is in the profile view. Shows a bit of a high spot, little ridge line. That's the crown of that entrance road. Comes back around and then it comes down the gutter, up the curb. Now it goes across that island that has some slope on it, like almost 11%, and gets to the curb at the top, and it goes into the parking lot area up in there. Okay. So again, something to help you evaluate what's going on. Now, let's go back out, go to view. We're going to turn layers on/off. That's on, or I'm sorry, to the view menu, thaw/on all layers. And now we're going to go back to view and freeze layers by pick. And let's turn off one of the, we'll click on one of the white ones. And let's look at the difference now between those. I'm going to go back to the profile menu, quick profile, screen entities. I'll hit OK. And this time, I want you to click over here on one side of the road, go sort of perpendicular across, and make sure that you're able to catch, you see these V-shaped contours up there on the cemetery. Make sure you're going across something like that. Okay. And now when you click, we're gonna get that same split view. You have to hit click again to make it finish up. So now, but what do we have? Remember when we saw going across the road and we saw the little sidewalk edge over here and it looked like it had a crown on it? But now when we look at it, once we get to that edge there, I see down here in my profile view, it hits right there. And then it goes dead flat all the way across to here. Well, why? And the answer is because it reads the elevation of where it crosses that contour line at that elevation. It goes across and it doesn't cross anything with any elevation until it gets over here and finds itself again. But from the shape of that contour and the shape of this other contour, we know the elevation right in here should be almost 2 feet or 1 foot, whatever that, it's 1 foot. It should be almost 1 foot higher than that dead flat area. Okay, but we missed it because all we're looking at when we choose that command and we give it the source information is as screen entities. So the only thing it looks at is where it crosses something with elevation. It has no awareness of the proximity of this other contour line right here. It's only picking up where it's crossing those. Same thing when you get up here and cross across this little V-shaped area. You can see right in from there to there, you see that's also a nice flattened off part of that feature. And the same thing would show up down here. Once I hit right there, it's going to be dead flat all the way across to the other end of it. And you can see it's dead flat by looking at these numbers over here on the right. It says the slope is 0.0%. And the elevation value is not changing. It's staying 1318. All the way across, even though right in there, you look up in the plan view, you see where my marker is. I know that that's really 1317, but I didn't actually snip that line, so it's not going to work for me. Now, all that being said, if you want to evaluate some things and you have a surface model already built, and I sometimes will use this to help verify if my model is correct, you can run quick profile and you can tell the source of it is a surface file. And you can look at up to 2 files. And if you have 2 names, and again, it keeps the name from the last time you ran the program in here. And so if those no longer apply, like, let's say I have a file name here that I'm comparing one next to the other. Well, if I don't want the second one, I'm going to hit that second button right here and then just choose cancel, and that'll clear that name out. Okay. So now I'm going to choose the first button and I'm going to set the file that we built yesterday. I think it was called exbad1. And I'll say open and okay. And now it wants me to pick a starting point or choose a centerline file or a previously drawn polyline. So now I'm going to just click from here. I'm going to basically click that same type shape to snip off that that little plateau area, but not quite catch that line. So now though, look at the difference. When I've got this, I'm coming down. I built that surface model, and I built that one from those break lines. And you can see right in here, You see there's a crown to the road, because it climbs up, gets higher, higher in the profile view. Yeah, because it actually happens across one. Should have been a little more careful there, but get in here. And as we come across here, look at the slope numbers over on the right. You see it's not, I mean, it's pretty flat, but it's not zero. And if I'm looking at the elevation numbers, there's 13, 17, 13, 18, and it's going to come down. When I get right here, it's down to almost 13, 17, which is what I would expect based on how we built that surface. And then it comes back up to 13, 18 again. So you see, I'm looking at this, and because I used a surface file, it's filling in the information by reading those triangles. Okay. Now, the nice thing about using a surface file is this little bit right here. You can choose adjust alignment if you've picked a point. And then if you pick a point, so my mouse is sticking. You know, let me exit and come back. Try this again. All right, so surface file. Okay, I'm just going to go across the street like this and enter. All right. So now if I wanted to adjust the alignment, I can click really got something going on with my mouse. I apologize. All right, surface file. Okay, click, and end. And now, if I adjust the alignment, there we go. If I pick that up and move it around, look at my profile view. See, it's giving me a real-time slice of my surface. And I can see right in here. So if I put this down right in there, and if I go back to this, you see where my crosshairs are in my profile view. Well, that's, I can look at that same area up here in my plan view. And I see, oh, that looks like a ditch or something. And sure enough, the contours indicate that. And I've got, you know, this little concrete head wall, that sort of thing. Okay. So it's a nice way to verify, you know, what if your modeling efforts have been successful or not. So now I've moved this around here. Let's do let's say even a 5-time vertical exaggeration just to show the slope. And we come over back now to this profile view. And if you track in the profile view, you see the blue crosshairs coming down the slope there, and they're hitting a little something here and jumping up with a little jaggly looking thing. So I might, you know, choose to go up here and try to see, you know, is that really happening? It looks like maybe it is. Okay, it comes down here, crosses the bottom of my pond, and it comes up this bank. It's the top of this berm. You can see here going across the berm, drops down across the floor of that little perched pond, and then it climbs back out the other side. Okay. So there's all kinds of little evaluation tools that can be helpful. And not only that, but you can, let's say you're working on something and you want to compare, one particular way you've modeled it compared to something else, you could just simply go out here and choose draw. And it's going to, if you remember, we did all that draw profile business yesterday. And I'm just going to say, let's go to 20 and 5. It'll be a 4-time vertical exaggeration. And I'm not going to draw the station elevation, just the grid and the axis elevations. That should be it. I'll say, okay, you could choose to make a new drawing from it, but I'm just going to put it out here on the side. And I'll see like that. And well, I've got my mouse is sticking on me, folks. I'm sorry. Let me. All right, so there now is so that's drawn it at scale. And you can set layers and colors and text styles and all that kind of stuff. But it gives you, that's a drawn, it's a polyline. It's a drawn profile, as if you had on up here to profile and says, create profile from existing or from a grid or triangulation surface, and you set up an alignment and you followed it along and all that kind of stuff. But really quickly, all I did was click, and then inside my viewer, I moved the endpoints of that little line around. And then once I had where I was looking at, I get, okay, plot me that. So boom, there it is. And, I would set things up to be, maybe a little more visibly apparent with line types, line weights, colors, etc. Okay. So never lose track of there always being some type of tool that will help you to evaluate what you have for data. Okay. So that's a lot of those analytical tools with different commands. And just like that was the quick profile lets you view it along a particular line. There's also, let's say you've already got a surface and you have this surface inspector. But I went to the surface menu and chose surface inspector. And let's clear all that. Let's just set this first one to that same surface. I'll say this is the surface name. I'll just be a plus mark. Whatever layer, text size, multi-text, so that's fine. I would just call this elevation. Okay, now, as long as you're over the bounds of the surface that you've built, when you run that command, you're going to see, as you track along, you see this little box over here. This is my surface inspector. Well, it's showing me, what's the elevation of my surface as I'm tracking. And so if I go here and put a spot there, maybe come here and put a spot here and one here, maybe one there, can just help you find out what's going on. And you could have, let's say you've got an existing ground and a design ground at the same place. It will put a marker down and read off, one versus the other and show you what those elevations are. Okay. And all it is just a block as a marker and a piece of text, or in my case, index, because of the way that's set up. Okay. And it just helps you, document your drawing as well. So if you're preparing this map to give to somebody else as a finished product, and you see these yellow markers where they're giving you spot elevations, well, that's a similar type tool to what the photogrammetry firm used to create these spot elevations. Okay.
Excuse me, Ken, I'm sorry.
Yep.
To have gotten to this point, I went to the surface inspector, and then we need to load the surface in. I think I may have missed that.
No, okay. Yeah, let me also find out. Jimmy, is that you had a question?
My question was, my question was just, like when we drew the quick profile, when we did the quick profile, how do you draw the crossing pipe as well, like for a particular section that I'm looking at, for the sake of just my presentation, probably would like to have like a crossing pipe just showing the area that I am
Sure.
doing a cross section on. How do you turn that on?
Well, it's really quite simple. Let me answer Pete's question first, and I'll show you very quickly how you can do that kind of stuff, because it's really neat. You can get some good results out of that. But Pete, so what happens was on this surface menu, surface inspector. Okay.
Right.
This comes up now down here, but like I had two surfaces listed from where I did the last time I ran the command. So I'm going to come down here at the bottom and choose clear. So everything's taken out.
Okay.
Now I'm going to load, but it's not, when I say load, see what it's trying to load is a surface inspector file, not a surface file. So what I'm going to do is see that ... over here on the side under this column called set.
I do.
Click that, and that lets you pick the file. And there's that file that we made yesterday. And there it is. Now, here's the actual file name. This is just whatever is going to be the label as it goes down next to that little plus mark. So I could call it, existing, and then I would load up my final grade surface, and I might call this one, design. And so when it gets labeled, you would see both elevations. Or maybe I want my design elevation to the nearest thousandths, but my existing to the nearest tenth, whatever.
Oh, I see. Okay.
So all kinds of ways you can do that. And again, it's just to document that. Now, let's go back to this question Chimizi had, and it's really sort of quickly simple. And I'm hoping I can. I have to restart my Windows to get it to start behaving. So let's say I've got a pipeline, or maybe a culvert or something I'm putting under a driveway entrance, any, something like that, or that, that maybe a buried power line, something that I'm looking at doing. I don't want to see that and see what it looks like in that profile view. So I'm going to go here to my layers, and I'm going to find, I'm just going to, actually, no, I'm going to find, all right, here's the storm culvert. It'll be green. And that's fine. Let's make it a little heavier so you can see it on the drawing. So I'm just going to draw a two-dimensional polyline. And let's say that line was, it started up here and it came down to here, and then it went across, say, to that, which is a head wall. And then ultimately down this other way, down through that. Through that ditch down there, okay? So maybe I had something like that. And actually maybe this is really in there. Now, right now, that's just a 2D polyline and has 0 elevation. But if I knew what those elevations were, I could create this as a 3D line, as a pipe, so maybe I've measured things and got them. But let's look at this. This is 1300. So that's 1299. So I'm going to say that pipe, maybe it's, let's say that's an 18-inch pipe, which is 1.5 feet diameter. So its invert is right at the ground there. So that would be 1299.5. So that's the actual end of that polyline. Okay. And maybe I went up here and I said, okay, well, there's 1335, 34, 33, 32. So it's 1330, 3, so 32, let's call it. So 1332 as its beginning elevation. Now, we could say, let's go to the 3D data menu. Go to 2D to 3D polyline by start and end elevation. Following the prompt, select the polyline to assign the elevations. I'm going to click here, and it shows you where the start is. So give that an elevation. I'm going to call that my 1332. And there's the end. Well, that was going to be 1299.5. Now, you may already know, and now it's going to ask me to select another one while I'm done. So I'm looking here. You may already can realize that because, it really needed to start below the ground, and then it sharply goes down this bank, and then it goes flat. So if I were to take a peek at that, it's not really what's going to work as a zeros. It's not going to work as a pipeline because you see it climbs out of the ground right there. See it? Actually, it would show up better if I did the surface and then added let's okay, so now you can see. All right, so it might work up there. Let's turn this on a little bit. Give it a little bit of transparency so you can, you see where it goes through here. So it's okay up here. It's still sort of under the ground, but it comes out, peeks out in the daylight. And so it's, above my surface. You can see where now it's above and below. Let me set my opacity back. And now you can see, part of it's under, the other part's out in the ground. So how do I show that though along my profile? Well, what you have to do to make this happen. See, I've still got a number of things selected. Select entities. Remove. Yeah, I'm gonna need to restart Carlson here in a minute. Well, I'll do that every break, but now it says I'm back. Okay, so so if I notice that that's got a problem and I want to be able to fix it. So what we have to do to see that as a pipe is, I mean, you could go to, you could create a 3D solid and start here and here and go there, but it's a lot simpler than that. Is if you go to this, I think it's on the profiles menu. Maybe I'll get it from here. Yeah. So I go down to the bottom under profile utilities, and I'm going to say assign pipe data. You see this section right in here of this menu is dealing with pipes. Okay? And it's just for onesie twosie pipes. If I'm going to do like an entire storm sewer network, I might want to look at the hydro module. But for now, I say this draw, I'm going to assign the data to the polyline. I need to tell it it's a pipe, tell it what it's made of, and all that kind of stuff. So I click that. And right here I'm going to get, remember I told you that was an 18-inch diameter pipe. And my pipe thickness, let's say, was a 0.25, say a 1/4 inch. And it was ductile iron pipe. Now, when it reads the elevation of this polyline, what is that reference on the pipe? Is that the top or the center or the bottom? You know, the invert. It actually wouldn't be the invert if I'm really strictly counting for that 1/4 inch thickness. But let's just say that's the top of that pipe, because that's what our surveyor shot. They went out there and they just stuck the rod down on the crown of the pipe. Okay. And you can even give it a name based on its layer, but we're just going to call this let's call it proposed culvert. So it's PROP space CULV, proposed culvert, doesn't matter. Say okay. All right. Now select the polylines that you want to set that data to. So I'm going to click that polyline that we had, finish my selection by hitting enter. It now tells me I have set pipe data for one polyline. Okay. So now the question was then, how did we figure out how to show that pipe? And that's basically a pipe, it could be a pipe crossing, and we'll do it two ways. We could do the profile along that, and you could see the actual pipe along its run. So let's go to the profile menu and choose quick profile by surface file. I'll keep that same surface file that I had. I'm going to say okay. And now it wants me to pick a point and choose a center line or a polyline. So I'm just going to the way it keeps. There we go. So I'm going to go from there to there and to there. So I basically snapped to the corners. And you see there's my existing ground, which, I see right here. I'm coming down. Let me go to a 1-to-1. So I'm up in here, which I should be, excuse me, relatively flat. And I hit here, and then I'm going to come quickly down that slope. And then I should hit here and be a little flatter than I really am. That's where I'm up in the air. Okay, so as I go out here to the end. So anyway, I've got this done, but I don't see the pipe yet. Well, I'm going to choose draw. And I get this set up. Now, again, this would be something I would do once and then load it up later. But I've got these sewer/pipe profile labels, and you can set things like, you know, the diameter of the material. If there are manholes, you put your pipe size, do all of those different things. And again, set all that stuff up ahead of time. The pipe crossing labels, and this again would be if I want to use you know, circle, and let's see where we'll come back to this in a minute. Let's see if we fill our pipe shape. Yeah, well, parallel pipes within a swath width. Sure, we'll do that. We'll show the pipe thickness, and we'll just do it with a solid. And that should work. So now we say okay, and we say okay, and say okay, and it wants to know let me get this. Pipe was using that to reference, and if I click that over here, now we should see now that's supposedly, I missed something here. As I told you how simple it was, and that's why I came across the problem. So now if I did that, let's make a quick profile again. And draw. Now let me do check that. There we go. Let's see. There, so why is it not doing that on the quick profile? Okay, so one more. I think I know what I need to do. So there's my existing ground profile. I need to save that as a profile file. And I'm just call it pipe -ex. All right, now save center, sure. Pipe -ex. All right. Yeah, I think this should have, but so now I'm going to, actually, I'm just going to exit that, but because I saved that file, now when I draw my profile in the profile menu, I'm going to add that pipe EX and say, okay. Oops, let me set a reference center line. so it doesn't have to ask me for that. And now it should pick up that pipe. And there you see it. Now it's showing this as crossings because even though it's a linear feature, but that's where it's actually intercepting, and what we showed it on the cross. Let me also set something up here. Standard. C dash. Yes. There we go. Now, so if I draw that profile and now in my sewer and pipe, my pipe crossing labels, I need to show these draw parallel pipe within a swath width. Let's say 25. Let's see what that does for me. So anyway, yeah, there you go. So it has found that, and you see where it comes across the line. Why am I not getting the rest of that pipe? It's only getting that first segment. All right, let me take a look at this. That's a long, that length. Now, what I would do with to try to see that entire pipe run is I would make the pipe itself a profile with some of these other tools like design sewer pipe profile instead of a quick profile, which is really meant to just slice this stuff and show you things along it. So if I have, just draw another one here and say one there, and I'm gonna make these into a couple of different center lines. I'm gonna say polyline to center line file. We'll call that one pipe -1. And one from here. Do it again, and I'm gonna call this one pipe -2. And that's this one. Okay. Now I'm going to create my profile from a grid or triangulation surface. There's my surface model. Type of center line. That looks fine. And the profile that I'm going to write is going to be called pipe dash. Pipe -1. And I'm going to have that along my pipe -1 center line. Okay. I'm going to do the same thing at the surface, except that the profile file to write this time is going to be pipe -2. And I will choose that as my alignment. So now I've got two different profiles and it crosses that. And if I had, let's say, another, let's say something like so, and I'm going to 2D to 3D by surface model. And I choose this. And I'm going to uncheck that because I'm just going to go endpoint to endpoint. I'll apply a vertical offset of -4 feet. And say okay. So if I look at this, just to verify, making sure that I am, yep, so I'm under the ground with that. So I've now got that. I'm going to go back to my profiles, and this time I'm going to do profile utilities, and I'm going to assign pipe data to polyline again on the top, and this time it's only a, say, an 8-inch. I will say PVC, and that's we'll say a 0.125. And that pipe name might be existing water line. And we'll say okay, and we'll tell it that. Okay, so now I've got two actual pipes in my my modeling setup. One's a water line, one's a culvert, and I'm looking at this along these two profiles. Clear some junk out of here. And then if you draw those profiles, I'm going to clear. I'm going to set my reference center line as my pipe 1. I'm going to add the profile. There's my pipe 1 profile. So there's my existing grade. I'll say okay. And I'm going to look at my pipe crossings. And that should be, and again, you've got all kinds of control over text and size and heights and whether you use leaders and all that. We'll get into the, that's not something we're going to have time to finesse right now, but I'm going to say okay. And I'll say okay, and I'll put that over here. And there now is, I get two different things. Now this one is still from that looking for pipes in a parallel pipe width. Okay, so that's because I'm within 25 feet. It looks at this line 25 feet within the swath. So if I were 12.5 feet, let's see, and I was on 1. So it looks at this and it sees, at this station, that's where the crossing is, but it then draws in the sidewalls as it's finding this pipe. It looks within that width to find it. Okay, it also sees this pipe. So that's why you've got in our profile, you've got these, what look like the length of the pipe, and that's really sort of a misnomer with this. So if I go back to draw that profile again, I don't have to do anything other than change some settings, and because yes, it will erase it for me automatically. Let's look at my pipe crossing, and let's uncheck parallel pipes within a swath width and show the pipe thickness It's okay. Okay. And okay, and let's just put this down. And now you see it found this 18-inch proposed culvert. And down here's my 8-inch existing water line. And that's, and you see that's right there at station 2+00. This is at station like 75. And if I look along, it's not a new one, I think these. I look along here, there's at station 75. Let's go and verify. We will turn my drawing inspector on. I'll right click. I don't need the elevation or the layer, but I want the distance along my polyline here. My polyline data, let's just do angle distance. I need let's do my distance along. Yes, okay. So as I cross that first one, notice when I get here and I get to that, you see how it says current distance, and there it gets to be like 70. Then I look over here, and that's going to be close to 200, remember. So my current, oops, I got to stay on the green line. My current distance is 193, and over on the other side of it's 198. So that's what you're seeing here is it's finding those. Remember this one, I dropped 4 feet from the surface. So 13, 10, 12, 14, 16, 18, 20, there's your 4 foot. And you can see right there, the top of that pipe was I set that polyline on the ground surface and dropped it 4 feet and then told it that was the top of my pipe. Okay, so that's picking that up. So anytime you have these crossings, let me turn this back off. Anytime you have features that cross, if you identify it, you tag it with data, then when you draw those profiles, they should pick those up. Now let me see if I know that one works. Let me go back to that quick profile and see if it will work. And so there's that, generally the same thing. If I go to draw it, and I've got the same settings that I had before. Let's go to OK and OK. And yeah, it doesn't. Apparently quick profile won't do it. I am having to save that as a profile so that when it sees those crossings, it will put them in. So quick profile apparently won't load those up, and it won't set your keeps the scale the same, looks like, but you know, it's got some different settings, right? So, but again, the simple part of that was we draw a profile. Now this time we're going to remove that one, but add pipe 2. And really should have to do nothing more than that. And you can see right there, it's finding that 8-inch water line, actually right up close next to the surface. 1310, because remember what I did with this line. See, it's crossing. It's finding this one. That's where that crosses. I should see 2. Because that's a pipe and that's a pipe. I may need to, oh, I know what. Yeah, that's exactly what. If I draw my profile now, even though I loaded that up, notice my set reference center line is still looking at pipe 1. So that's the stationing it's using. So I need to make sure that I use the proper center line. So now when I plot my data down, I'll get, there's that big one that crossed the proposed culvert. You see it's sitting right there in the top of that ditch because it really needed to have been buried a little further. And where did my other, there, I accidentally deleted that apparently. I think I had it selected. So let's just repeat. I'll draw a profile. Now you should see them both. Because I had accidentally deleted the pipe. Now that there they are. So there's the water line, 4 feet deep, my culvert where it crosses. And notice, see, it's an ellipse because I've got a 5-time or 4-time vertical stretch on my draw profile, whatever it is. Whereas now it's, yeah, it was a 5-time. So if I make this 20 and, well, let's make it 10 by 10. So it's all at 1 to 1. Now they'll show up as circles. There's your 8-inch water line. There's your 18-inch proposed culvert. And again, you've got control over, the color, the line style, line weights, the scales, all of those different things. But the key to all of that is when you assign that pipe data, you're assigning a diameter, a wall thickness that you see hatched there, and so that one's a little bit thicker than the other one was because it's a bigger pipe. And it also has, let's put in, let's label the pipe polylines with the length, the size, the slope, and the material. And we'll just go back out to our pipes, and as you can see, text and such was a bit large. So if we label the pipes, all of that, my text size, I'm going to call points. 0.05. Pipe material, let's just do the diameter and the material. That one, that one. So there's 8-inch PVC and there's an 18-inch ductile iron pipe. So it knows what it is, and it knows the flow direction, because this is the uphill side, there's the downhill side. Same thing here. So it generates those as well. And we could have over here, instead of just the diameter and the pipe name, remember when we assigned the data, we gave it the name. We could have instead told it to, type in the material. So if I want to look at So drawing, identify pipe polygons. I think all that's going to do is simply find them. Yeah, so the highlighted two. Check or search the drawing. So if we search, so there's a highlighted two polylines. It shows you where they are, and you can see that's dashed. You can see that a little bit. It's not a super easy way of showing, but you know, it at least allows you to see where those are, or you could have picked it and checked it. All right, so and again, this is just something on the profile menu on the utilities section. And it's this little 4 commands that you've got in here that you can assign that pipe data to it. You can also, pick up sewer laterals and such like that. And this is just in the general profile settings. The real pipe design stuff is in our hydrology system, where you can actually design, storm sewer networks, sanitary or utility networks like water lines or gas lines and such like that. And there's a wealth of additional tools that does very specifically. And all of these things over here, you can get all kinds of different labels and such, and you can generate profiles. And once the pipe profiles are drawn, you can adjust them in the profile view, and it will update the elevations and keep everything tied together. So there's a tremendous amount of information in there. So, but we're getting sort of stuck in the rabbit hole a little bit here. We need to get back on task here so we can really get these key concepts, because I want to show you that. How to manipulate that 3D viewer, because it's so important to what it is that you're trying to do when you design things, when you design a building pad, or you design a pond or a stockpile. You want to try to compute the volume material in a stockpile, those kind of things that you're going to need. Need to look at things in your 3D viewer so that you can, assess them just visually to see if you've got any particular issues that you need to resolve. Okay. So with that, I think we're well past time for our break, almost a half hour past time, but we'll go ahead and take our break now. It's about 5 minutes till, it's 4 minutes till. So let's say at not at 16, at 11 minutes. So we'll come back at 11:11, and that'll give you your 15-minute break, and then we'll get into that viewer and we'll talk about using that as part of our process. Okay, any questions so far? Everybody good? All right. I will see everybody at 11:11. We'll pause this and pause our recording. All right, let's see. I am back if you guys are.
Yeah, I'm here, Ken.
Okay.
Ken, just a silly quick question. I must have blinked. When you first identified that one pipe, running along that driveway, what routine did you use to do that? I mean, I was following along, and I didn't want to kind of stop watching, trying to fiddle around looking for that control. But
so what did I do to turn this into a pipe?
Well, what did you do in the very beginning? It was just a 3D polyline.
Well, yeah, so like this one, I do a 2D polyline, then I made a 3D polyline from this.
Okay.
My surface model. And I told it the ground, and I selected that. And
then the elevations front
well,
in the beginning.
What I did was, if I'm turning this into a 3D based on the surface model, it's going to read the surface that lies underneath it. Now, if I have this button or this box checked here, then everywhere along this line that it hits an edge of a triangle and changes, it's going to put a vertex in this line. If it's unchecked, then the only thing it's going to do is read the elevation of the start point and the elevation of the end point. Or in
Okay.
the case of like here to here to here, it would be at this vertex, at that vertex, and at that vertex. So everywhere there's a vertex in this line, it just samples the ground and sets that elevation, ignoring the bumps and rises and falls in between. If it's turned on, it will read all of those bumps and rises and falls all the way along. So I turned it off so that I only wanted to start and stop elevations. And then I said right here, apply vertical offset
Yeah.
-4 feet. So I set it 4 feet in the ground. So when the winter comes, it doesn't freeze my water line. All right.
So then in that regard, when it comes up to, let's say, like another pipe crossing or within some kind of a 5-foot parameter or something, it'll then it'll put a vertex in. And then in regards to the elevation, so you never, in the very beginning, when you put that 2D polyline, you converted it to 3D, you never assigned one end of the polyline to be that elevation 1300.5, and the other end was it?
Yeah, not this one, not the second one I did. The first one I did 2D to 3D polyline by start and end elevation.
Oh, that's what it was.
Yeah.
I by start and end. Okay, I was watching along, and I didn't want to interrupt the class time, but
Yeah, no, it's all good. See, every one of these options is a way of elevating 2D lines to 3D. Okay, so we did one by surface model. We did several by screen entities. We did some of those yesterday. We did by start and end elevation. You could do by text or by text with leader if you've got like a parking lot with all of the corners labeled with top of curb, bottom of curb type text.
right.
All kinds of options. We just don't,
Yeah, no, this is very interesting stuff. All I'm
Sure.
being very well presented, and I'm enjoying the class. So
Well, good. All right. So that's helpful.
yeah, well, I mean, for whatever it's worth, it's always nice to get a little feedback.
Sure enough. All right.
So
Good deals. Okay, so moving along a little bit to try to get back into Erica. Again, let me if any of you guys have, and I'm not trying to push you into backing up and hitting a different class or spending a lot more money necessarily, but if you have any desire or need to go back and sort of reinforce some of the basics, that because we're by necessity having to go pretty quickly through them to accomplish what we're doing here, but that's in our fundamentals class, and we have that from time to time. It's I think we just finished one a couple months back, and there's one coming up, and I don't know when. You'd have to check the website, but those are, again, we spend 2 days, but we go through things like just what we talked about there and about how to work with these polylines and how to set their elevations and all kinds of stuff. So again, though,
right.
And so I'll leave it at that. I think if there's any interest, consider.
No, absolutely. Yeah, it's all interesting stuff. I mean,
Sure. But the key takeaway though of what we're talking about here and me showing you all these different ways is to let you know that there are many different ways to figure out how to do this stuff. And the fact that, this is still just it's a 3D polyline, but it's just a CAD native entity.
right.
Carlson is aware that it's a pipe, but IntelliCAD doesn't know the first thing about it being a pipe. If I just, double click it, it just treats it as a polyline. So,
Of course.
So at the end of the day, if it's easier for me to hit there and select this polyline and go into these vertex and step through, point to point to point and set individual elevations, there's nothing that says you can't do that, but you'd have to stop and look at that. All right, that's between 1314 and 1315. Call it 1314 and a half. Go to the next one, and that's it. So it looks like 1309. And that's just based on where it happens to hit on the contour line.
Right.
Or if you've got, a book of field notes that, hey, boss, I shot this culvert invert, invert in, invert in, invert out. And that's what they are. And so you can set the data accordingly like that. Just select it up, go in here, and change your elevations. Okay,
Sure.
there's not a thing wrong with doing any of that. And now keep in mind, when we set those first things up, we did 2D to 3D polyline by these various methods. And so all we did was make it a polyline. In fact, that's all that
So
is.
Why did you start that with the 2D polyline in the beginning?
Just because it's easier for me to draw 2D instead of having to fiddle around, type in an elevation.
Okay.
But you certainly could. That's a very good question.
Right.
You can draw it as a 3D and snap to those things and read the elevation. But now, again, what happens is these things that I'm showing here are just polylines. Okay, there's remember, one's an 18-inch pipe, the other one's an 8-inch pipe, but they don't look like pipes, do they? So you can, however, let's see, can I draw? Label pipes, pipe depth. Trying to see if I've got anything in here that I can, draw a pipe 3D polyline. I wanted to draw it as solid, which I can do in the hydro stuff. Let me see what this one draws.
So this is actually only available in the civil. This is not available in survey.
Correct.
Yeah.
All right, so I now did. Oh, okay, I see what that does. If you wanted to do this in one shot all at once, instead of drawing a 2D, converting it to 3D, on that tool right here under Profile Utilities, you can draw a pipe 3D polyline, which is just like draw 3D polyline, except it now adds a couple of things. So if I draw a 3D polyline, you give it the diameter. Let's make this one a 15-inch. Keep the wall the same. We'll call it a CMP, corrugated metal pipe. And maybe it's the bottom. We're going to put it on a layer called pipe. And we'll call this one existing culvert. We'll say, okay. Now watch what happens. This is much like draw 3D polyline, where you can show the options or not, prompt for the elevation of slope or not. And if you do, you can add you can put it in -4 foot or whatever, positive 10 feet, doesn't matter, elevation adder. You can create a dual 2D polyline, meaning you'll draw a 2D on top of the 3D or underneath it. But let's use the surface model from the file.
Right.
And say again.
Yep, I understand.
Okay. And then we'll say, okay. All right. So here's now my ground surface, and it's going to read the elevations as I move the mouse. You see it's changing there. So if I go from here, let's go ahead and snap right to there, and you see it's going to read that as 1336 exactly. And then I'll come down to here. And then
Oh, and then
maybe
it begins to show the slope in the distance,
here.
okay?
Yeah, and so now I'm over here in between the contours. Okay, and it doesn't matter because it's reading the surface file. It's not reading just the triangles.
Right, right.
I mean, just the contour lines. It's reading everywhere in between. But it is, however, let me see. Let me show you here. It does, however, have, you know, it's creating it in 3D as you go along. So it's just as if you had put that right on the ground surface everywhere you click. So I clicked once there, I clicked once down there, over here and over there. Okay, now let me show you another little means of editing. So I did that and laid it right on the ground surface because I unchecked that elevation adder. You know, I could have put in something else. So, but if I need to do that, there's a couple of ways of doing that. And again, go to your 3D data menu and it's change elevations, either differentially or absolute, meaning it goes to a specific typed number for an elevation, which is not what we want. We want a differential. We would say, okay, and positive increases, negative decreases. So if we say -4 feet, ignore zero, doesn't really matter. Select the entities. So I would select that there, and it's actually just going to drop it 4 feet for me because I did that change elevation. There you can see.
Right.
4 feet under. Now, there's something else you can do with that is just instead of, see, I can't really, now I could, because there's so few of these vertices, I could go to each one, subtract 4 feet and set it that way, okay? But I can also do this. If I move this is pure CAD, nothing to do with Carlson. If I move this object, all right, here's my move command. I'm going to move it from, now I'll use this corner to snap to. I'm going to move from right there, click. Now, where am I going to move it? Well, I'm not going to change its location horizontally, only vertically. And I'm going to type in a coordinate value that is called relative coordinates. Instead of typing in the numbers, I'm going to type an @ symbol, which means relative to the point that I showed it as my starting point, go this amount of motion. I go 0 on the X direction, comma, 0 on the Y direction, comma, -4 in the Z direction. Hit enter, boom, it's there. Stayed right where it was, but if you see this in 3D now, it's going to be 4 feet further down. Look, hang on, sorry, missed.
So now it's 4 foot deeper than it was.
Right, so it's like 8 feet deep. Okay.
Oh, because it is 0, 0, and then -4. I got you. Okay.
Well, the first thing we did was change elevation by differential -4. So that changed it. And then I moved it from there at 0, 0, -4. So -4 and -4 is -8. So it's now 8 feet deeper than it was. Now, the problem with that is when we created this, we drew it as a pipe polygon, which assigned the elevations to that. So let's take a look at that and see what
having assigned the starting and beginning point versus just putting in a 3D polyline and running along the surface. Is that what you mean?
No, when we said draw a 3D pipe polyline, when we did that command, it's exactly the same as drawing a 3D polyline, except it also asks us the size of the pipe, the material, what layer to put
Right.
it on, that sort of stuff. So once we do that, and we told it to read the surface, so it got its initial elevations 8 feet higher than it was to before we made those changes. My question is, the data that is assigned to that pipe, does it keep that separate from the physical? Like, could I pick up that 3D polyline and move it across the site and it still thinks it's back where it was with those same elevations? And and I don't know the answer to that. We're gonna find that out with this right here. We can either
It's probably good to know.
well, yeah, I think what I'm gonna do is to draw the profile. I'm just gonna look at that second profile over there. And that is one we're looking at, pipe 2. And so we're gonna come here and we'll just leave this now. So this is going to actually recognize that as a pipe polyline. So it's going to, excuse me, it's going to put, see, it should have said EXCULV. It should have recognized that. So it may have, let me see if it's still a pipe. Profile utilities, identify pipe. If I identify. Let's see, by pick. I'll select that one. It's not set for pipe. Okay, so apparently when I did those changes to it, it broke the pipe data.
Oh,
So that's good to know. So, so I checked that by going to identify the pipe. And so now I'm going to assign the pipe data to the profile, this time 15-inch CMP existing culvert. We'll say, okay, and we'll set this. So now it was set the first time we drew it, but it didn't, because we modified it, it didn't update it correctly. So now that we've done that, if we we're going to see, there's that excuse me, there's the see, did you see what I did there? I just double clicked the profile and it brought up the profile editor, and as I said save, it went back and put in this crossing. It resampled it. Now it changed the labeling. I would need to set that correctly. It looks like it's putting station values. So 0 plus 72, whatever the rest of that number is, and then 8-inch existing, 18-inch proposed culvert. So it's putting in a couple of
right.
Something or others. But all I had to do, once my settings were correct, all you got to do is just double click any part of that that jumps straight to the grid line setup. Here are your pipe crossing labels. Let's take the station value and we'll give it a space afterwards and we'll set it to 3 decimals. We'll say okay, so okay. Erase existing there. So okay. And now, so if I'd said erase existing, it would have updated and created those. So now there's my station. I guess.
Yep.
And again, all that does are just plain old
Right.
pieces of text. Now it's this part. let's put the invert elevation. No, it's not able to match. I think my mouse has got some kind of thing screwing up here, but if I use, all right, select profiles, label, text, wrong. Yeah, I've got something going on. I need to get, let's see, sewer pipe crossing labels, name, elevation, invert elevation. Wow, really? I don't,
Yeah, you would think it would just give it.
well, it does normally, but I've got something going on, so it's not catching it. Let's see if I can. Yeah, see, I can't get anything to do with that. I've got something else.
That's fine.
Yeah, so anyway. Let's see, sewer pipe crossings. That. So a space, 2 decimals, name, invert. Yeah, I don't.
Yeah, I'm sure it's just some
Yeah,
Mickey Mouse setting.
there's something. I need to restart is what's going on. But anyway, you can see when when you pick those up and just make those changes, they react to the fact that you've got that pipe in the system. And if it were up here, if it were captured up here on any of these others, those would update for us automatically as well. Okay.
Right.
All right. So now back to the viewer. Because this is something I want you guys to get used to doing over and over and over again as you're doing your work, because it's going to help inform your process. You're going to be able to look at this stuff and know whether something has a problem or not. If this were something in my data set, and I looked at that and I said, yeah, okay, that looks like that's where my pipes are and all that. And I go to build something from it and I get something really wacky and I can't figure out why. Well, as long as when you look at this stuff, if you take a pic, oh, look what I did. I've got a bad elevation on that vertex. Okay. So, and I wouldn't have seen that, and I can tell it very quickly when it's like this. Okay, so I spin that around. Now, again, I can do it out. Right. There we go. See, I can, do it here without having to go to the 3D viewer. I can say, oh, well, God.
Right. You still there, Ken?
I'm
Right.
here.
Oh,
here.
okay. Yeah, he must have crashed his system or something.
I
Yeah.
think, yeah.
Or maybe the wife came down. You guys all keeping up with this, or?
Yeah, I've done quite a bit with this before, so it's more of I was looking forward to like earthworks and stuff, but I've done, I think just the
Yeah, I
crossing.
was I'm kind of hoping this afternoon or the rest of the morning you start getting into that sort of thing as well.
Yeah, designs, like the
The
designs,
design, right.
design part of it. Yeah, I was looking like their volume calculations from surfaces, like
Right.
ramp designs. I think he's going to get to it, at some point. Hopefully.
Yeah.
Right now, what time is it right now?
I'm looking at 11:36.
Okay, so we have 4 more hours, right? About.
Yeah, because I think he's been touching on a lot of background yesterday as well. I mean, it's all important stuff. Him not knowing, I think, where exactly everyone is, in their experience levels.
Yeah.
I could have probably done, with half of what was done yesterday and more focused, as you say, on the design.
Yeah.
So, well, I guess we're still on Zoom, right? I mean, we're all still connected, except he's just.
Yeah, he's probably trying to get back in.
I was going to ask him. I mean, there have been times, where we've developed topos, like in an arbitrary system, and then they come back and they say, oh, it should have been, in this system, it should have been in that system, and. I mean, I'm assuming that once you create a surface that you could just literally lift that up or down. I mean, right? I mean, you'd probably have to
Yeah, you can. There's
contours.
another. Yeah, you can. I mean, depending on what you want to do, but you can be able. There's a tool called. Let me pull it up again on that surface. Surfaces. So if you go to surface triangulations and utilities.
Yeah.
Think you can load up your tin surface. Yeah, whatever surface that you have, you just load it up and then you click next, and it just tells you like if you want to elevate it like 10 feet off, you can do all of that stuff in there. Like it's a math function that you can input and will be able to do that for you.
So that's under surface, and
then it's on the surface, and then you go to surface triangulation utilities.
Oh, triangulation
utilities, yes.
Oh, I see. So then you need to. Oh, you have to load the tin in.
You load your tin in. It comes in. And then you click next. And then it just goes up and tells you exactly like what you can do. There's so many different functions that you can use. You can match like if you had like a surface that wasn't matching a particular grid other surfaces, like I'm talking about like the dimensions or resolution, you can match it there. There's just so many options there that you can do with your surfaces. Yeah.
So I mean, if you were to spend time, in regards to designing pipes and all of these break lines and all, I guess you could. I mean, aside from the surface, I guess you could just window everything. Well, you don't want to move anything that's on the zero elevation. That you don't want to do. Oh, here he is.
Yeah.
I guess I'm assuming that if you did need to move this datum up, oh, there he is.
Yeah, so can you guys hear me all right?
Yeah, I can hear you. Yes, sir.
So when did that drop off? I'm sorry, I don't know what caused that. I just got kicked off my whole network and then it came back on. So
probably 5 or 10 minutes ago.
Really? Wow. Well, my apologies. I was sitting there talking away.
Oh, is that right?
Oh yeah. So anyway, all I was really talking about is the fact that, the Carlson commands let you do things, a lot easier for us not to have to think about it. Like if you remember when we drew the, the polyline and instead of having to type the coordinate or to click a point or try to figure all that kind of stuff out, if we already had points in a coordinate file, all we have to do is use a point number. We'd say 1-4, and it goes in, it looks up those point numbers, reads the coordinates, and it feeds that to AutoCAD or IntelliCAD behind the scenes, which is really just running the polyline command. But to us, we've got this front end on it that's a lot easier for us as land development practitioners to deal with. So that's something I'd encourage you to do, is to explore a lot of these Carlson commands that do things, because, I can do every bit of all this stuff manually. If you look over here at, well, looks like I erased them.
I don't, are you sharing your screen, Ken?
Yeah, I thought I was, but apparently.
Well, maybe it's just me, but oh, now I see it.
Well, there you go. Yeah, yeah.
Hi, sorry, I don't know what knocked me off. I had to go up and maybe check. My wife is working from home today. We've never had an issue when she does that, but maybe something happened. I'll see if there's something on her end. I'll check that out over lunch. So anyway, so all of this, if you remember, I'm not going to go back and
Right. You were in, I think, the viewer, and then you were rotating around, and I think that's when it crashed.
Yeah, so if I draw, my my profiles, and say and yeah, so and point to, yeah, so I might draw my profiles like this and get all these pipes across, and it picks those up out of the fact that it thinks they're 3D pipes, okay, as it crossed it. But if you see where it's stationed, that
Could I ask you a question, Ken?
yeah,
Having gone through all of this at the end of the project, everything gets submitted, and all of a sudden the client says to you, he goes, "Oh, you guys have it in the wrong datum."
yeah,
He bounces this thing back. I mean, all the contours, of course, and all the spot elevations, that sort of thing.
mhm.
How would somebody go about now edit? I mean, without,
Well, you would do a coordinate transformation on the stuff you would set up a number of control points, let's say, and you'd have to be a point that you knew what the state plane coordinates are for that point. Let's say you're on 5,000, 100-foot elevation, but it's really 1.8 million, 250,000, 1,300. So how do you get everything over to that? Excuse me, there's a number of ways, and one of which
I'm more interested in like the Z-axis, like up and down, because the datum is bad. Not bad, we misunderstood, it was wrong.
you used the wrong benchmark to get everything going. So yeah, so all you would do there is just, you would select, what you wanted to change, and then run the move command, okay, the standard move, and click a point. So you click a point to start from, except my mouse jumped twice.
Yep. And then just,
But anyway, you pick a
0, 0,
point
and
to
then
start from, and it can be a point you just pick in space, and then you would say at 0, 0, and then type in the differential.
and all those entities on the at 0, 0, they would all move up as well in elevation.
Yeah, if you selected them. So
right? I mean, if you selected them, so you have to make sure not to select them.
Yeah, if you didn't want to select them, then you
You
would
have to,
not include them. In fact, what I would do in that regard is I would select this. I would look at my 3D viewer and I would spin it up
oh,
sideways like this. Okay, so I can see the stuff that's at 0. And then I would go to my settings tab and click this button right here that says set the CAD viewer to that. I say, okay, go. And now when I looked at, all right, there's everything down at 0, right?
yes,
So now what I would do is select this and say move.
move.
Click a point out here in space. And again, I'm going to type at 0, 0, let's say 200, and it's going to jump up 200 feet higher than where it was. Okay.
And that would include all the brake lines as well, all your pipe
Well,
designs.
everything you selected. Now, what I selected there, I didn't have the brake lines turned on. So,
Oh, okay, okay.
but the pipes are, and so let me show you what this is. See that 1310?
Yeah,
But if I select that, what's its elevation over here in my properties?
1510.
Yeah, see, so it went up 200 feet, and also so did that 1310, the piece of text, although it reads 1310, it is sitting at 1510 in its properties. Okay, so
So then those contour labels, then, I mean,
well, keep
we
in
ma-
mind, those labels are just pieces of text.
right, okay,
So if you do something like that, you need them to update, you have to go back to your surface menu and say, contour labels, and you would, contour the elevation label, or a local elevation label, you would recreate them. Now,
you'd have to recreate them. Okay,
Yeah.
okay,
because when you do all that stuff, they're just drawn polylines and pieces of text. Okay, so
right, right.
it's not like when you had the link labels with line work and the bearings and distances, and when you change something.
Yes,
Yeah, see that part's new to automatically update. These labels won't. These are static labels. So it just reads the
Okay.
elevation and puts it down there. Okay.
and
So
then that original surface, oh, and even those other values up there that you picked on the surface, like 1300.9, 1299.9.
yeah, all of these little spots, yeah. And these over here, see, they still say 13.
Well,
Even
we didn't actually move the surface
correct.
because we,
Okay, that's what I was getting to next, and glad that you picked up on that, because where is my surface? If I look at this in my 3D viewer, and if I add that surface that I had made, all right, so there it is, and I gotta toggle the color here to make it work. And now I'm gonna spin it up a little bit. Oh, well, look at that. The surface didn't change one bit. All I did was physically move drawn things in my drawing. So how do I fix
Right.
that? And the one answer may be, well, I got to go back and rebuild the surface. Well, yes and no. Okay, you could. And certainly nothing wrong with that, but there's more tools in the surface menu, and there's this thing called triangulation file utilities. And if you choose that, you get this little editing box, and I'm going to go up here at the top right corner and choose load 10 file, and I'm going to get that existing bed and choose open. There it is. I can toggle it and see that it's there. It's sort of like the viewer, but not as full fledged. All right, so from here, I'm going to go to this little button down there at the bottom right that says next, and I get all kinds of things I can do to it. I can merge my 10 with another 10, so I can put in a design surface on top of my existing surface and maybe merge it together so it becomes a single surface called final surface. Or in this case, I'm just going to come up here at the top left and say add. And see that it says add a set value or another 10 to all of the node elevations. Well, I'm just going to choose add. And do I want to add a value or 10? Well, in this case, it's a value, and the value is going to be
200.
right. So, okay. All right, it's done that. And now I come down here and I'm going to say, I think if I go to exit, it will prompt me to save it. Yes. Do you want to save changes? Yes, I do. And I'm going to call this one, let's say existing bad. One was now existing bad and 200 because it's still not good. So I'm not make it call it existing good. All right, so now I've got another surface. And if I look at that surface, again, load this stuff up in my 3D viewer. And I'll go to my model tab and add that surface. I think you can see.
And all your spot
not-
grade elevations have
Snug the whole thing up to all of those things that I moved by 200 feet. It also brought my surface model up to be at that 200 feet as well. Now, you see those pink dots? Those are there. You know, these things out here in space, and they're slightly above in some places below or not mixed. They're not exactly right on the surface. And the reason for that is that when we built the surface, we didn't include them. We only included
Right.
the curves, okay, because when we did include them, this long ramp went down and stopped along this line of those points back that you can see back over here. So that's how I know that, and they're on now, they're in my viewer. But I could, I don't know if I know what, let's see, V topo.
we had a spot. So in regards to those yellow spot grades,
But they're DTMPs, I think. Let's see, there we go, yeah. Now, the yellow spots are, you see how they're right there? See that X, and watch how if I get closer, it just sort of disappears because it's sitting right on that surface. All right.
but those values are those values have not been updated.
Correct. That is correct. Those values are not. But if let me go out of my viewer here and we'll show you that. So if I needed to, see that says elevation 1300.76. So if I go to my surface inspector, I'm just gonna take that out and change this to be the X. Let's make the text a little smaller here. We'll change now to a different surface, the one that we added. And so I would come here and say, put one. Yeah, let's see what happened. When I changed files, it put this back in here. I just wanted that blank. So
Those little spot grades then are not linked to the surface.
correct. Yeah, they're just, and especially because we got it from somebody else. You know, it wasn't.
Right.
All right, so I'll put these others out here so you can see them. There's 1501, 1500, you know, and this one was. Wow. A little different roundup here.
And then those other ones, the older ones, the 1300 series being on a dedicated layer.
Right, well, so, I mean, if, you know, a quick way of doing that is this, I'm gonna isolate this layer.
Right.
Okay. Now remember, all these things are just in text. Whatever. Now, let's get rid of these ones we already did. And well, what couldn't be simpler is go to the edit menu under text. And we're going to just simply do a find a place. Find it, is it here? Edit. Select text. So I'm trying to find the exact location where they put this thing. Otherwise, so it's not edit text. Oh, here it is, right there. Sorry, I just missed it. Finding your place. We're going to find what, and that was, well, there's a possible issue. There's 13 and some of these other digits. It's also going to mess that up. Let's see. Let's look for colon space 13. That should work. And let's replace that with colon space 15. Look in the whole drawing, and I could have done it like that. Or since I'm isolating, I'll just say, look at the current layout. Search up matching the case, whole words only, wildcards. You can look inside blocks. So remember those yellow ones that the photogrammetry firm gave us? I could also have chosen those to do as well. And simply say replace all. And so now those are all updated. I can restore my layers. Let's isolate these and see. Are these blocks? No, those are just text. So I can do the same thing there, even though this is a block. Now that's going to be a little different because that doesn't have the colon. So I would have to, maybe I'd want to verify those. And here's some that are already 13. Oh, did I change those to 15? I don't remember. Yeah, I think so. And so here's a case where I've got, 1297 needs to be 1497 instead of.
So these entities here are not actually points. That's just text.
Oh, that's correct. Yeah. Now, were they points? In which case, let's do that.
Right.
Points. Let's go to 3D data, spot elevation, convert spot elevations to points. Let's make Carlson points. And it's going to be, our spot indicator is a line work cross, because those are, it looks like an X, but it's not, it's just a line.
The spot indicator.
But we have to process block references. So it's going to look inside those blocks. And is the spot part of the elevation label? No, but sometimes you'll see a spot elevation where the decimal is the actual spot. But we're going to leave it like that. Line work cross, this, a base elevation. There's nothing to have to add, like they didn't strip off the 1,000 and just put 310. So there's no base elevation. We'll say, okay. Let's choose a coordinate file. I'm going to go to a new one, and I'm going to call this one T3 global spots. Okay, starting with point number 1, that'll be fine. Select a sample block, which will be that. And now select a sample of the spot elevation text, which will be that. And spot elevation line work, enter for none. I have none. Okay. So did it do that? I don't think. Not yet. Okay. Why did it? Spot elevation, Carlson points, no. Line work cross. Cross this block, expand the block. Don't really need to do that.
Would you have to update
I think what it's
CRD file from drawing?
No, remember that's only if you already have Carlson coordinate points. Okay.
Oh.
So now the sample of the spot elevation is there. Now select this spot elevation line work. It's not working right. Let's see here. Sign spot elevation. Let me see. Civil. Reading data. Convert spots to points. At elevation of spot, the stores in the point. Okay, it's not insertion point. No, it's no. 7 choices are available. Line work, leader, cross, text plus a text letter X. Point, circle, art, or close line work. Well, it should be a line work cross at the intersection of the line work cross. All right, block references. If checkbox include Carlson searches only text entities for elevations, but if checked, will search block references for elevations that are stored as attributes. So we don't really want that. Use this option. Okay. Expand. Symbol designate. Okay. All right. So it didn't recognize this. If I say line work cross, I'm going to use that cross symbol, but they're blocks. So I'm going to need to expand the block references. So not sure this will work. So that's select a sample of the elevation text and then line work none. No, it's still there. So what I would have to do is, because the text is not part of the block, this is still a block. I need to explode all of those into crossed lines. So if I select all of those and just explode them. Right, then okay, so now if they've been exploded on a different layer, I'll select that and that too. Now the spot elevation, line work cross, that's good to go, and no need to even do that at all. Now select this, select starting one, a sample of the text, a sample of the spot elevation line work. Select the entities to process. Well, now I can do this. So I now have 53 Carlson points.
With the elevations?
With elevation, right there, see them?
Beautiful.
And so I've got those points. I didn't draw the points. Well, it drew the points, but it didn't draw the point number, elevation, and description. I could have done so, but now what I would want to do is, I should have put these on a specific layer. So now, if those points are Carlson points, I can move those 200 feet and those will change.
Those will update. Yeah.
Yeah, yes, they will. And so when I simply select those, or let's go to use points menu and let's adjust coordinates and let's translate the points And we're going to make no delta northing, no delta easting, but we will do a delta elevation, and we have to click on to process elevations. And so now our delta is going to be 200. And define by direction distance when it's override existing range of points all. Say okay, boom. It's now translated those 53 points. And if I double click that, you can see it now has an elevation up here of like 1500.9. Okay. Now again, I could have simply moved the points with a CAD move, or you can see how easy it is with the Carlson stuff. Now, I can also then next, let's do this. I'm going to make this my current layer, the spot elevation layer. And I'm going to now select. Oh, wait a minute. First, I'm going to make another layer, make a new layer called Freeze Me. And I'll make it frozen just so we can see what's going to happen. And if I select one of these pieces of text, right click and select similar, I'm going to now come over here and put this on Freeze Me, just so that we keep the brightness. There they are. And I'm going to select that and select all of those. And those I'll just get rid of. They're just those exploded blocks. And now I'm going to set my drawing setup here a little bit better. Make this a 50. See how that's been part of what's been. I moved my text size was all right. So next thing I'm going to do, so I select that and I see that that is a Carlson point. I'm just going to select all of those. I'll erase them. But now my coordinate file still has those points in it. So I'm just going to draw locate points. And I'm going to set to use that same symbol, the X. And I'm going to make sure I use elevations, look at on a real Z, use point numbers, just so we can see them all. And let's put these on the dash topo dash spot. And anything else I want to do? That's, I think, fine. Let's just draw them on. So now those all 53 of those points have now been placed on that layer. And I'm going to fix a couple of things by them. First thing I'm going to do is, because I can't really stand that ugly text, and I'm going to make that say Arial narrow. And I'm going to redraw my points. I think, do I want to do, if I select all 53, yeah, easier. I'm just gonna give them a description, but it doesn't matter. So if I draw those points again, draw locate points, and now instead of doing that, I want to change the attribute layouts, which I have to do on my points menu or points defaults rather. So instead of this attribute layout 2, I'm going to use 3 so that my elevation is going to pop up there at a diagonal. And now I'm going to draw locate points, making sure I say erase and redraw and just draw them all. All right, so now they're there, but I need to turn the point numbers off. So I'm going to simply freeze by pick, turn that off, and now there they are. And
Done.
yeah, and if you need to change your color, now this is on a layer. The whole point is on the topo spot, but there's a layer now, or a series of layers called PNT number, and that's one I just froze. Description, elevation, and so you can change that if you wanted to match it back to where it was. Okay. And you can do, you know, individuals if you need to rearrange because something's over top. You just grip edit those things and move them around. Okay. But so now, if we go back to what we had before, and let's do this. Let's go to quick select. And let's select, no, let's not do it that way. I'm going to do it this one. In my viewer. We're going to set the view. Exit. Now there's all that stuff again. And let's remember those points are there now, right? See them?
Yep.
Okay. So now if we just move those, go from here at 0,0, let's put them up 300 feet higher. Oops, 300. See what happens? You want to update the coordinate file? Yep, I sure do. So now there they are. I'll go back to plan view. And now if I look at that point and double click on it, I see it's got an elevation of 1801. Okay. So the point is where the point is. I didn't, let's see, can
So the point was at 1801. Why? Did you
Because
move them up again?
yeah, I moved it up another 300 feet.
Oh.
So
Oh,
now,
but it didn't up.
yeah, so now if I update the drawing from the coordinate file, all I really want to do is have it update the text. All points that are nice points, update all symbol. It's not really what I'm looking to do. I could certainly just redraw them all, but I've moved a couple of them. I was trying to preserve that part of it. Otherwise, so that should have. Now there's some delta 0 over that new 545 points was translated. No, it's not good. So 0.00001. See if that does. Yeah, see that did it. As soon as you moved, I moved it up by 0.00001. So that,
Oh,
yeah, so that force. So I'm gonna do a translate. Now I'm going to say this time a minus 0.00001 to put it back down to that distance. And I'll say, okay, and you'll see them
Right, right.
tweak just a little bit, but I'm only showing to 2 decimal places. So, that's, now I'm back down to a clean differential. Okay. So, yeah, so a number of ways of doing all that, but you got to remember when we got that file originally from the photogrammetrist doesn't use Carlson. All they gave us was a file that had blocks for markers and pieces of text for elevations. So
Right.
that's how we had to bring that up and take all that information and use it to build our model. And so what I was telling you about, these Carlson tools, let's say that's my original alignment that I looked at where I picked up these pipe crossings. And so I can do all the stuff that I'm doing manually. I can say, well, what is the distance? I'm just going to use a standard distance command. So what is the distance from that endpoint to this intersection being right there? And, oh, sorry. God, I'm in 3. So to the apparent intersection of one more time here. Now the apparent intersection there. So that is what, 71.39. So then I could, have gone over here and read all that information, go to, 71 point, whatever I read. I must have missed the intersection a little bit, but, I could find out what the distance is to get that information. I could then go to that as a line and find, what is by list an elevation of that, was what, 1805.00. I could, try to find it real close to there. And so, oops. Yeah, 1805. I don't know if that's going to match up here exactly. Yeah, it says 1305 when, it really should be 1805. Remember, we've raised everything 500 feet. So, I can create every bit of this kind of stuff manually, but you can see when you're doing it back and forth and back and forth and back and forth. Whereas when we did the draw profile command, we had a 3D pipe, we had to assign elevations. We've done a model. We let the alignment cut the model to generate this ground. And let me set this back up to 1. Got points ahead of, there we go. So I could have it, cut my surface model just by saying, give me, you asked me for a starting point and a stopping point, then I'm going to take care of all that stuff in between. Whereas I could go back and do this manual. I can say, well, how far is it between this contour line and this contour line to find that endpoint and figure out that interpolated elevation? Then come along down, okay, there's that elevation. Come on, and I can build everything that this is doing, but it would take me forever. Okay, so all of that stuff is happening behind the scenes and you don't have to deal with it. And that's what I want you to take away from the class is that these Carlson commands are not doing anything, any magic, nothing's going on that you couldn't do completely manually unassisted in the CAD system. It's just, making it practically possible because there are certain tasks that would just be impossible to do. Okay. So any further questions on that till we're going to get into some grading design when we get back after lunch?
Lunch, yes.
Okay. So,
Yeah, I just had a question based on just the grid files. There's the difference. I just wanted to know the difference between setting it as a grid and versus a local.
okay.
Yeah, I just wanted to know the difference and how that works, you know.
All right, now keep in mind this, and what he's talking about is my drawing setup with a grid or local. And grid means it is a projected north and east grid system. It projects it to a flat, like state plane is a grid system. But the Earth's surface is actually on the approximation of a sphere, so that the lines that run northward actually converge. They're not parallel. Okay, neither are the lines that run east-west. Well, they are parallel, but they're curved. They're not planar lines. But we think in terms of this X and Y. Now, so what? Okay, that's well and good. So what's the difference between grid versus local? Well, if we choose grid, we can set a particular planimetric projection. System America State Plane 83, and I'm in the Pennsylvania South zone with the World Geodetic System 1984 as my datum. Okay, I could, if I knew specifics in my particular local area, if I knew a particular scale factor, and this is to allow us to convert distances that we measure that would be grid distances on that flat paper map to ground distances, which are actually along the surface of the sphere, because one's an approximation of the other and they're not exact. So that lets us set up a scaling factor that we could set that up. Now, most people don't really do this, and you won't even see a difference if you're just doing like local site construction type things. Where you will see some of this take effect is if you're doing really long or large scale projects, like if you're doing a pipeline, a cross-country pipeline, and you're crossing several states or something, you'll see those differences show up. And so that's when you would take effect with those. Now, if I say local, and even if I keep all this stuff, then that's telling it, instead of using a predefined projection, if I use local, notice I've got over here now where I can define the localization. Whereas when I'm in grid, I can, well, if I change this to predefined, user defined in the grid, I can define the projection. So I would put in, let's just call it my horizontal projection. I would give it a name for a datum, give it an ellipsoid definition. Okay, so this gets into these. Now I've got 6 factors of transformation. I've got my translation and rotation values, my dx, dy, dz, my rotation about the x-axis, about the y-axis and the z-axis, and then a scale factor. So those are my 7 parameter Helmholtz transformation is what that equates to. But then I can define, what latitude is my central, or not latitude, I'm sorry, what longitude is my central meridian. Okay, same thing for where does my latitude originate? Give it the scale factors, how wide is my zone, false east, false north, and all that. So I would create that completely from scratch if I were a complete masochist. That's why we have these that are predefined. And if I said, let's do a predefined, define it, but I'm going to add from a predefined system in the USA, NAT 83 high accuracy reference network, LM Pennsylvania. Oh, crap. Missed it. Pennsylvania, LMNO, south. All right, so there's that. Okay. All right, now this one I'm going to remove. All right, so there's that. I'll say okay. And so that gives me a starting point because I've loaded that. And if I edit that, see, this is what it's filled out from that. Okay, here's my ellipsoid, the geodetic references in 1980, but maybe I'm using some, different, like maybe I'm, back on the old Clark of 1866. That was the one that we used for years and years and years. But notice these values here are now filled out because that's what that predefined file said to do. And we've got a false easting of 600,000, but our northing is not shifted. And this is just to make the east coordinates significantly bigger enough than our north coordinates so we don't accidentally flip-flop them when we're dealing with those numbers. All right, so that gets into a lot of geodetic type things when we're defining that as projection. That's if it is that grid projection. If it's not, if it's a local system, now I'm going to define a localization. And what this means is I'm going to observe some points, and based on what I've observed, I'm going to say here in my local area, this is my localization. I'm going to define, my points and tell it what they're supposed to be into this system that I want to be using. Okay. So there's my horizontal transformation. I could be simply saying, go by plane similarity, the rigid body translation, which means everything I observe as a rigid body gets picked up, moved, translated, and rotated, but it doesn't get warped. It doesn't get scaled. Or I could use that Helmert 7-parameter transformation, just like I was talking about in that last thing, where it does warp everything based on those translations, individual translations in each of the axes, as well as individual rotations about those axes and a scale factor. All right, so anyway, getting well afield, but that's what that means. Now, the reason I wanted to point that out, though, Jimmy, is because I wanted to make sure you're asking the right question. When you saw that setup, we say grid versus local. This does not mean that we're going to be using grid surfaces, okay, grid terrain models. That's a completely different understanding of the word grid. That is simply the transformation. So if that's what you're meaning there, then we've been talking about triangulating contour, but you're talking about, especially in the mining stuff, is if you use a 3D grid file to model your surface. Okay. And so, excuse me, that's where it's going to look at all the data and and then sample it at a regular interval. So I'll show you real quick what that differential is. I'm going to turn everything on, then I'm going to isolate this and this. Let's see, let's isolate this. This and this. Okay. Now I'm going to do what we've been doing before. I'm going to triangulate the file. This time I'm going to call it ex-good. And I'm going to shrink parameter reduction. Let's just turn it to low, densify. Don't have to worry about any flats. I'm not going to draw contours and I'm not limited here, so that should be good. I'll say okay. I will select all my data. I've got a couple of seams and vertical. Ooh. I've got that's let me back out of this because I'm not going to save that. We moved all that stuff up 500 feet. Let me get back to that original file. Okay, now I'm going to look at all of that. And I'll triangulate and contour that, keeping that 78. No, contour's good. All right, so north 0, low, bump. That's good. Say okay. Select this. Now I don't have any of those 500 foot. There we go. All right, so so I've now got one surface made by triangulation. Okay. Now, what we do in the mining software, the grid files, is we do something sort of similar. Let me draw a boundary here in a minute. Well, actually, I'm not going to draw. Yeah, I'm going to do it anyway. I'm going to draw a shrink wrap on this thing called BDY, cross gaps. Low, so okay. There we go. I'll just deal with that. Now, when we're making a surface model out of the data that we have, but we're going to use it like we do in the mining software where we're using gridded surface files. Here's the difference between that and a triangulation file. If I go to surface menu and I choose make a 3D grid file. So I'm going to create this one, EX grid. Now, my source data is going to be from, I can use screen entities and let it read this stuff again, or I can just, since I've already made a file out of that, I could use a triangulation file. But let's, this is the source. This is going to provide the information to create the grid file. Now, what's my modeling method? And this has to do a lot of this stuff like inverse distance, polynomial averaging. You've got Kriging, you've got least squares, and you've got this ABOS, which is an algorithm that deals with, I forget exactly, nearest neighbor, Voronoi approximation. So this is really some of the high-end math, and it depends on the type of data you have, and it's really geared toward when the data you have are a bunch of drill hole data points where you've got an XY location, you've got an elevation, and it needs to know, well, how do I connect? How do I assume the surface that you're looking at, in which case might be the top of a coal seam. So the first place I encounter coal in my drill hole, in my borehole, that's the top of the coal or the bottom of the overburden. And then it looks around till it finds the next drill hole, which might be 300 feet away. Well, the coal's not going to go in a straight line between there to the other, but it uses all of that stuff as an aggregate total to give some kind of a statistical weighting to how it might bump and warp and carry on with those different things. That's a whole different science and philosophy. So there's just a little more to go than we can go through with this. All right. But if we just do our triangulation, we'll say read the data, triangulate the data, and then apply a grid to it. Okay. So when we do that, we'll use this inclusion boundary around the edge here that we created. And we're going to set a grid file, and we'll specify dimension, we're gonna go say every 50 feet. We'll say, okay, and we're gonna go from here to here. And we're going to now select the inclusion. So it's going to clip off the surface at that edge. And there are no exclusion boundaries. Now select the things we want to generate from. There's our source data. And boom, you see how quickly it created that surface. Now I've got that surface. And if I look at it, let's look at our existing grid. There's the first one. And it's, you know, pretty nicely modeled because I used the 3D breaks. And so you can see all the curves and everything is nice. And, you know, I've got a couple of spots. There's that wall right in there. Okay, now let's compare that to this one that we just made as existing grid. Well, that doesn't look anything at all, only barely like what we're dealing with, okay? In fact, if I turn off the solid bit, you see what it's done? It's gone every 50 feet and dropped the point down to make a grid file. Now you can see it's got some elevation change, but it only went every 50 feet and took a picture of the data that we had. So over here's this big pond. And here's that little raised mound, but you see it's not very conducive to our work. It's very fast. And it might be all we need if we're dealing with large ore deposits in the ground. You know, I don't need to see the crisp edges of curves and such, but I could make the trade-off. And those files are very fast to calculate. All right, so I'm going to take this and I'm going to call it EXGrid-Finer. And this time I'm going to set my grid position from another grid file. So I'll use the same one. And I'm going to set my actually I have to do it here. All right, so I'm going to go every, say 2 feet instead of 50 feet. I'll go from here up to here. No exclusion. Now notice how much longer it's taking. Okay, so we finally got through everything, but now I can view it. And now you see it's considerably closer even though it's still made up of a grid, a regularly spaced grid. You see it's every 2 feet, but it's now at least approximating. But where you need to find values are up there on those curve edges, all right? And for an example, let's go back to our profiles, quick profile. Use a surface file. Let's take our first file. We're going to say the existing grid finer. We'll compare it to the existing grid. And let's just look right across this structure like this. All right. So the first one that you see I'm tracking, and in the profile view is that white line. You see, that's the finer file. The red line is the one that was done with the big 50-foot grid. Now notice and understand what's going on here. You know, I'm really far off up here in this right-hand area, you see the difference in those two profiles. I'm not very accurate writing here either. As I come across the parking lot, my big system just is like a straight line. But when I'm comparing this to the next layer down, say the bottom of the coal, next to, a layer above it that might be the bottom of sandstone and the top of, or limestone, all of these different things, I don't really need that kind of nuanced difference. So I'm going to set a larger grid file, and I'm going to just work through those and use the speed of that grid file as opposed to this triangulation file. Now, showing you also the difference between, excuse me, and I'll take the file that I made by triangulation, which gets everything that it creates, and then even the tighter grid file that I had every 2 feet, you can still see there's difference. Let's look at, we'll look right in here. Road, oops. All right, so so yeah, you see my white surface, that's picking up that the curb drops, excuse me, the curb drops and the shoulder and the road crown. Now the red one, which is the large, or it's the 2-foot sampled grid, it picks up things like the crown and generally the slope of the bank, but you see those little nuanced areas like right here where that comes up and just should drop off with that very sharp change in elevation, but it's not. It stops sampling here and it doesn't sample again until it gets over here. So that's the trade-off. And it's a trade-off of speed versus precision. So there's not really, in terms of the civil module, what we do on the top of the ground in civil is we want to use those triangulation files. So that is the difference. Now, if I wanted to create a grid file that was fine enough to catch those curves, I'd have to make the grid dimensions like the biggest I can make them is every half a foot, because that's going to pick up that differential from the height of the curb. Also, from front to back of curb is half a foot. But now the problem is you might be a quarter of a foot in front and go to a quarter of a foot in the back, and you won't catch the actual edges, whereas triangulation uses the actual edges wherever those edges are. Gridding does the triangulation, it builds the triangulation file, but then it overlays a fishnet with knots tied in every corner, every 50 feet, every 20 feet, every 2 feet, every half a foot, however size you make the grid. And then it drops it down and reads the high precision surface, reads the elevation there, and then throws everything in between away and just extrapolates in between each of those grid points. Okay. Now, if that's what you meant by the grid file, Janizi, because you're working with mining data, that's what you have to remember there. This other part of the setup under this drawing setup grid is the horizontal system only. And it's going to almost always be set to either none or to one of these, like state plane or universal transverse Mercator or some type of predefined geodetic coordinate grid. If it's set to none, and it would be fine. You could just set it to like a local system like 5,000, 5,000. It would be local, but this word here doesn't mean local. exactly. It means you're going to use observations, and most often they're going to be GPS observations, which are surveying information, and you're going to tie whatever it is that you survey, what values you find, like 5,000 for northing and easting, and 100 for elevation, and then you're going to pair it up with another series of points that have different real values, and so it's going to read those two relationships and decide how much to move your information into this other. It's called localization. So you're taking local observations and you're converting them to match a defined grid system. Okay. I know that was long-winded and all of that, and I hope that answered your questions. And it's well past our time to get to lunch. So being 1:45 here on the East Coast, Will and Pete, thanks for your perseverance here. And Jamaiza, you won't have to eat quite so early today, but we'll go ahead and break for lunch. We'll gather back at 1:45. All right. So I'll talk to everybody then.
Again,
Yep. Oh, Pete.
I'm back.
All righty.
Anybody else on or?
Jamaiza, Will, if you're there, give me a thumbs
Huh?
up.
We have you thumbs up.
There's Jamaiza. Okay. Wait, no,
I'm back.
Will's back. Okay, so we're all well had our good little break. So hopefully cleared a few cobwebs out. And so we can see everybody can see the screen okay, I presume.
Yeah, I'm good.
Yeah, okay. All right, so I'm going to go to view and turn thaw on all layers. And let's talk about this 3D viewer real quickly and see what some of these controls can do. So again, like I said, we've got this 3D viewer, and it's basically in two forms, either the drawing viewer or the surface file viewer. And it's really the same viewer, but it's just a matter of what you load in first. So when you load in the drawing viewer, it asks you to select things in the drawing. So these are like lines, and they can be, 3D faces, anything that has some elevation will show up. The surface file viewer will ask you for a surface file. Now that also adds a couple of other tools like editing tools to, add break lines, modify points, that sort of thing. But basically the controls are all the same across, how it works. And it's so quick and easy to work. And here's the thing. You see the command says drawing viewer, and it's got this little 3-colored cube. In fact, that's the name of the command. If you look all the way down here on the bottom status line, you see if I hover over that with my mouse, it tells me that that command allows you to view the selected 3D faces, polylines, lines, and points in 3D, and then it gives you the name of the command that you could type if you wanted to do that instead of choosing the menu choice or the icon. So that icon and the surface file viewer, which is called cube_file_nm or cube file name, would be its command. So the other thing to notice here too is when we look at the menu, a couple of these commands have little icons beside them. And when you see an icon beside a command in the menu, that tells you that that command is available on a toolbar somewhere. It doesn't tell you which toolbar it's on. Okay, so you have to sort of find that out, and once you know where it is, you can, help yourself to it. Now, these two commands happen to be up here on this toolbar, which if I hover the mouse over the little handle there, it says surface. So that's on the surface toolbar. You might be tempted to think it's on a view toolbar. It's not, it's on surface because it deals with surface data. Okay, so it's just real quick and easy to grab the command and then select the data because it's asking you to pick data. And then when you're finished selecting, hit enter. And it's going to pop up into this viewer. Now, again, that's a resizable window, repositionable, all of that. Okay, so what do we got? We initially come into this viewer in plan view, and if you move your mouse, just hover the mouse over various parts of the data. You see out here on the edges, the cursor looks like a letter Z and a little rotating double-headed arrow, like a little curved double-headed arrow. If I move it in toward where the data is, you see it changes and becomes X, Y with those arrowheads pointing up and pointing left, up, down, left, right. Okay. So that tells you that when you're in that mode, whenever you click and hold the mouse and move the mouse with the button held down, it's going to choose those particular actions, right? So here's the rule of thumb. If you look over here on the right, that icon right there, second from the left, is the rotation mode. That's the one that's pre-selected when you first come in. The one next to it is a pan mode. So no matter how you're oriented, if you choose that, you could then, just pan the drawing around. Now you can use the wheel mouse without having to use that. So you can be, even in this mode, click and hold the wheel on the mouse and pan just like you normally do in the CAD, the regular CAD window, okay? And you can zoom in and out with rolling the wheel on the mouse. So that part still works. You don't really need that part or these other two on the right, other than one is a zoom previous. And then you've got toggling the shading of surface elements. So those had to be 3D faces. Like when you load up a surface file, those would be there. You've got this arrow icon, which now switches to this. And look down here on the bottom of the screen. As you hover over something, it tells you what, something about, let's zoom in here and say, look at this bit of curb line. See, I'm not clicking, I'm just hovering the mouse. And as you walk along that, it works like the drawing inspector does. And so, and it'll tell you what the item is. Like this contour line's a lightweight polyline. It's on a layer called V Topo Minor, and an elevation of 1312, right where the cursor is. Now that will be 1312 all the way along it. And the length is the length of the segment of that particular polyline. Now for these 3D polylines, you see the elevation. It shows you the layer, shows you the range of elevation. So that line goes from a minimum of 131001 to a maximum of 131377, and the elevation at the point is 131193, and that segment has a length of 8280. Okay. Or actually, it might be it's the total length of the item. Okay, that's what that is. All right, so that gives you a little bit of information there. And you've also got these clip sliders at the bottom. So if I wanted to clip, what's near to me, or clip out what's far to me, and I'll show you how this works a little more effectively. once we're rotated up. But if I clip near, I'm going to take this and drag it to the right. Now watch what happens when I finally encounter some data. It's going to start clipping it from the nearest point down. And the more I drag it, the more it clips, okay? So that's clip near. Clip far just goes the opposite direction. It goes into what's farthest away from my eye and then starts clipping it. The further I go, the more it clips up into my data set. Now, top and bottom, in which you can actually put in specific elevations if you know them. But when that happens, in this case, this is exactly the same as clip near and clip far because I'm in plan view. Okay. But where it becomes different is if, and I'm going to go back and grab this rotation cursor. And I'm going to put the cursor sort of down toward the bottom of the data, but not so far that it turns into the Z. I'm going to make sure it stays XY. I'm going to click and hold the mouse, and I'm going to push it straight up. And so now I've got, and I'm just grabbing an extra little chunk of it, letting the mouse up and grabbing another bite. All right. So now, and you can use those sliders no matter what cursor you've got. So now if I clip near and far, you can see what happens when I clip near. It's taking what's nearest to my eye and clipping it off. What's far from my eye and clipping it off. So if I only wanted to look at, say, that little pond over there and this other stuff is sort of in my way, I might clip the back and then clip the front down to that little area, and then I would, zoom in to get a little better position of it, okay? Now, you can also synchronize front and back, in which case when you do this clip, it's going to, you see it's, they're working in tandem. I'm only moving the one, right? And you can do the same thing. Let me put these back to no clipping. And if I synchronize. And you could do the same thing. What did I do here? Oh, sorry. You can do the same thing with the top and bottom synchronization. Now, the difference here, front to back or yeah, near and far, which is front to back. You can see how that works. It's based on the position you are looking at. Now, top to bottom is going to always be elevation based. It's not line of sight based. Okay, so that lets you, slide things up. So start shaving off from the top and we get there we go. So and then you're left with, just certain things at certain elevations. Okay. So that could come in helpful. To be honest with you, it's not something that I've found a lot of use for. But it's there in case it's possible for you. You can also, when you use this arrow, and if you're hovering over something, let's say that 1310 contour line, and you see the little information down here, but if you double click it, you can actually change the layer, or you can set it to 0 elevation in case it's something that was accidentally elevated. You can make it 0 elevation, or you can add it to a selection. So let's add to the selection. And let's then double click this, that little white edge there. I'm gonna add that to selection. And let's maybe grab this other contour that's sort of parallel to it. And the other
Yeah,
one.
I gotta tell you, dude. You're sitting there fucking, oh,
Say what?
what?
Were you saying something?
No, I was mumbling to myself. There's a part of me, Ken, I kind of thought we were gonna start delving into like roads, that sort of thing, heights of curbing. Well, no, I was kind of expecting some of that. I know it's getting late in the afternoon and it's almost quitting time.
Okay, yeah, that's fine. We do need to get to those and we'll get some grading in.
Good. Thank you.
Yeah.
I'm sorry if I was rude. I didn't
No,
realize.
no. I'm just showing you some of these controls here. So
No. And it's all
really-
good. I
Yeah, it's really important to understand how to use this stuff. So when you're doing this stuff, you can verify what you're doing. You can't do it without doing, without using these types of tools. So to learn how that is, now I'm gonna leave it to you to then to sort of investigate all of these different controls over here, where they are. But here's the secret to having, to how you position yourself, how you want to look at a model or a given selected set, is when you come into the viewer and your cursor is in that changeable state and you're in that rotation icon, then what you want to do is over here on the right, make sure that this middle line, the Y axis, is clicked on to lock. Okay. But you don't want to spin around that. And the reason we're going to do that is because this is a sort of a little memory technique to help you do it. So it's not just random rotation. So what I want you to think about is when you look at this in plan view here, think of this as if you were standing in your driveway and you're looking at your garage door that's closed down over your garage. And that's, it's one of those solid doors that just rolls up. It doesn't roll up, it doesn't bend, it just kind of lays up. And so I'm going to put the mouse down toward the bottom before it becomes that Z cursor. And I'm going to click and I'm going to push this up. And my goal is and I've had to go back and get another bite of it, I will. I want to lay it back at a mostly oblique angle like this, okay? And then once I'm like that, I then put my cursor, and you lift the mouse up, put the cursor down at the bottom, even though it'll work anywhere around, but put it at the bottom and then just go left and right and spin yourself around. And then when you get lined up the way you want to do, just roll in with the wheel, okay? And so now that will start to become second nature to you after you've learned to, work with this for a while. And it's an extremely valuable tool to be able to position yourself around. If you need to, just zoom back out, get yourself a new, further perspective on it, and then zoom in and make your changes like that. Okay. And then you've got things like you can change your vertical scale. You can set your color by elevation. We saw some of that yesterday as well. Okay. Again, on the settings tab, sometimes you would come over here and choose this to set the view in the CAD file. And then when you exit, it comes back and shows that. Now, you remember when we were looking at that and I'd said, add to selection? Well, in the viewer now, and I'm back in my CAD system, you see they're actually selected. Oops, let me put that back where it was. There we go. So, some tools that you can use with that as we go to build that surface file. Now, let's close this file and let's get something that's not quite so heavily laden and take a look at some of these other tools. Let's open up a file. And the file we want is going to be called roadway design base. We want to choose open. Okay. So now we have what looks like it is actually a contour map. And we see a drawn polyline. It says start of the alignment on one end, says the end of the alignment on the other end here. Now, what do we have? If we just look at that, if you select it, you see the whole thing selects. And you look over here in the property and say, well, that says it's a AECCDB surface 10. Now it's got, you know, all kinds of properties for it, but that's a clue that this came from Civil 3D because Civil 3D creates those AECCDB surface 10 objects right in the DGN or in the DWG file. Now there's two ways you can handle that. You could explode that just like it's a block. And then that turns it from this AECC object into a block. So you'd have to explode it again. But then that explodes all of those little drawn contours into little line segments. So, but you know, what else do we have in our drawing? So if I select everything and look at it in my 3D viewer, I don't see anything in it. Okay, so it looks like, you know, it's not there. I've got, if I uncheck ignore zero, the alignment comes up because it's drawn in zero, but I don't see any of that stuff. And that's because it's not a 3D face or a polyline or a point or something. So we have to figure out what to do with that. Now, I also notice, or I happen to know ahead of time, that this see, this is what this is really consisting of. It's a bunch of 3D faces. Now this changed its view because that's the way Civil 3D handles that object. So that's a known big complete object. It's not just a series of lines. It's all of those triangles, everything is all included. But it also has as well, and if I change my if I change my shade mode, let's see if I can get it with this to back to wireframe. No, that's not gonna be, let's see, 2. And
Ken,
yes,
I don't mean to be rude. I pulled up the drawing and all I seem to have is, I guess that polyline. It seems on the preview, when I toggle the drawing, it resembles exactly what you have. Got all my layers on. I don't see any of the contours. All I have is that alignment, that polyline, I guess.
I have the same issue as well, Pete.
oh, so you don't see those contour lines and such?
No. I mean, on the preview, when I toggled on to open the drawing, it all seemed to be there, but
yeah, because that's the thumbnail sketch that you would normally see. Will, do you see yours?
Yeah, mine looks like yours. I see the well, I just see the contour lines. Yeah, mine looks just like yours looks now.
Yeah, okay. All right, so what version are you using, Pete? What year?
I'm 2022.
Yeah, you just installed the new one, right?
Yes, that's correct.
Yeah, okay. Jamizi, how about you? What version are you on?
I am using the 2022 with AutoCAD, right?
Yeah, okay. Oh, you guys are both on AutoCAD.
Right.
Bear with me a quick second. Let me double check something here. I'll load up the AutoCAD version and see, there may be a setting that you need to be able to see. That's what's known as a proxy object. And it's to allow you to use it. You have to have object enablers loaded. And you typically would.
Yeah, it had something to do with the AEC. It says, because I had a warning before that, it said something, saving the drawing will update any AEC objects into current version,
Yeah,
which
and that
will be incompatible with earlier version.
yeah, and that would be okay. All right, come on. I hate Autodesk, I really do. Okay, 683,177. All right. So I'm going to open and I'll navigate to our location, which is road way design base. And it's currently used to agree. Yeah, I'll go ahead and open it, read only, it doesn't matter. Now, last save, but you want to, okay, I'll continue opening. Now it's right here. Did you get this box up?
I
Nope.
did not,
No, I did not.
Neither one.
no.
Let's see what
You know
it
what?
looks like.
I'm just gonna close this drawing quick and then I'm gonna try and start it up again.
Yeah, I restarted it and still the same case, but I just have the polyline.
Right, it's just a polyline.
That's correct.
What version of AutoCAD do you have?
I've got 2022.
And it's full AutoCAD, not AutoCAD LT, right?
No, it's AutoCAD.
Yeah, okay. Well, it has something to do with object enablers. I don't know why that's not showing up. Let's see if you, should be another, let's open up a different one. Let's look at roadway design base 01. Let me see what that would be. No. All right, so that gives us, we still have this proxy entity. Let's see.
Yeah, I see what you have in the middle of it. However, the contours, I don't have that
Okay.
for the second one.
Right. Let me see what else. Roadway, road nets. Let's try grading design. Try grading design 02. Let's see here. Yeah. Go ahead and open grading design 02. And that should get,
Grading design 02.
yeah. So that should now be surface.
This drawing was saved by an application that was not developed by AutoCAD. We're gonna continue opening. Oh, here we go. Okay. All right.
So now you see this
Yeah,
one?
this image I have now.
I have
Okay,
This file I have.
all right. So we're going to leave this open, and let's also open that roadway design base. And when that comes up, you'll get just that drawn alignment. You won't see this business in here, okay? Now, for you and for anybody in particular, this might come in handy for you, because when you get DWG files from your design firms, they're going to quite often be in Civil 3D format. They did their work in Civil 3D. If you happen to know that they did, and I know that because I can select this and look over here and see that, all right, that's an AutoCAD proxy entity. Now that's in my AutoCAD file. If I'm in IntelliCAD and I select it, it tells me it's at AECC DB Surface 10. Okay, so it's the very same thing. I've got, both files are here. So instead of, exploding and then trying to recreate that surface, what you need to be aware of is that Civil 3D drawing files contain surface data, point data, alignment data, profile data, pipe networks, all of that stuff are included in the DWG file native. So if you go to the file menu and choose import Civil 3D, when you do that, it's going to read that out of that extended object. And watch what happens when you choose it. It wants to know in a coordinate file, in case there are any coordinate points. I don't have any. I'm just going to, accept that and say open. And it's going to run through a bunch of this extraction business. And when it's done, it's going to have recognized that found a surface called phase 6 original ground. You want to create a Carlson 10 surface? Yes, I do. So I do that, and it comes up here and asks me where I want to put it. That's where I'm going to go say save. And there was one already there. So I'll go ahead and just overwrite it. And it finishes up. And so that's the only thing it found was that. And now you look at what's happened. You see, now I've got individual polylines representing those contours that we had before. So it sort of exploded the block and extracted out the contours, and they're drawn. However, I also have this phase 6 original ground as a surface file. So I don't even have to build this surface file. It's already built for me. Okay. Follow what
Yes.
happened?
Yeah, I'm good.
Okay. Now, if you also spin this thing up, you'll see that, all right, there's all of this business. And these are 3D faces. So if you take a look at that, so you can't see it. It looks like there's a line drawn around it, but you can see, okay, there it is. And so there's a bunch of 3D faces that I don't need. That's just something that AutoCAD does when it creates surfaces. It puts those on there for visualization purposes. So if I look at that, and that's on a very called C topo boundary, but I'm just going to select one. I'm going to right click and choose select similar, and then I'm going to delete all of those. I'll go back to plan view. And now you should have just the elevated polylines and the alignment left in the drawing. And of course, the only thing at elevation is that outside polyline and those drawn contours. So that's really what we're after. We've got that existing ground. Now, a couple things we can do here. Let's see, I've got, this is elevation 150, that's elevation 145. So I'm on a 5-foot contour interval. But so we're going to use that as our design base, and we're going to design some things into it here. But for those of you, Chimizi and Pete, you had this, but you couldn't get, now you've got this part going, right?
Yeah,
That's
I
correct.
already did.
Yeah,
So we're going to go back into that file, and if you've also opened up this file, what I want you to do is go over there and I know you can't see that other stuff, but just select that polygon, that drawn polygon. And then right click, choose clipboard, and say copy with base point. And just type 0,0, hit enter. Then go back to the other file that you also have open. Choose right click, clipboard, paste to original coordinates. And you might get this box up, and if you do, just say show proxy graphics and go on. Okay. And so now when you look at that, you can see the thing that I just pasted was that original alignment. Okay.
so I'm going to copy this. Oh, copy with base point.
Yeah, just copy with base point and just type 0,0.
0,0, and then we're going to switch over to the other drawing.
Yep.
And then and then paste
Yep.
0, 0, 0.
Yeah, or you can do
Oh, yeah,
that,
perfect. Thank you.
or you can just say paste to original coordinates, either one. Okay, so you got that?
Right, we got
Yeah.
it. Yep.
All right, now we're gonna clean up some space here for us to work. We've got some contour labels and contour lines. I want to freeze those off, or so I'm gonna go to view, and I'm going to freeze layer by pick, and I'm going to pick one of the intermediates, one of the index, one of the labels, and say enter. Okay, so now I'm just left with some stuff to work with. Now, let's erase by layer. We're going to erase, say, this center line and these station values and all that, so that we're going to essentially, the only thing I want to have is that thing we pasted in just a minute ago. Okay, so the quickest way of doing that is if you just come out here, let's click in the upper left, drag down to the lower right, and select everything like this. Okay, now before you do anything, then zoom down in here and hold the shift key and click on that white line. Now everything else is selected. And at that point, you can just hit the delete key. Okay.
So how did you start that selection, Ken? That window?
Yeah, I just with no command active, I just went.
Oh,
like,
okay, done.
Yeah, okay. And got everything, and then I held the shift key and clicked this so that I took it out of my selection set. I'll get everything there. I zoomed in, hold the shift key, click, and that goes out of the selection set. And then I delete.
Correct.
Okay.
And then we're going to delete.
All right.
Done.
Now,
Okay, thank you.
all right. So now you can go back to this original file and close it. Don't save it. All we did was use it to get that line from. Okay. And let's change this name from grading design 02. Let's do a file save as, we'll keep in their same folder, and we'll call it road design, maybe dash mod. Okay. So we've modified, and so that's sort of our way around it to get to where we are. Now, you have, as part of your data sets, you have that existing ground, that phase 6 existing ground, that was included for you, but we actually did it over here on the extraction side. Let's see, this is this one. When we did the file import. So Will, you should have had that happen. So I'll just want to take that as well. That's fine. And then I'm going to select one of those faces, select similar, and delete them. Now, just to verify what I have, making sure I've got everything that I intend and don't have stuff that I don't need. I'll zoom it up. I see I don't have any of those skirt 3D faces, so that's what I want. All right. So I'm now good to go. I'm going to freeze by pick the major contour, the minor contour, and be done. I now have the same thing that you guys should all have, this same type thing. We've got a drawn polyline, but we don't have it turned into a roadway yet. So to talk about road design, get this back out, is we've got a couple of concepts that we're going to talk about, because there's a few things just at minimum that you're going to need to design a road. You need a center line alignment. That's my horizontal alignment. You need a profile or a vertical alignment, and then you need a cross-sectional shape or a template that you want that road to follow. And that would be something that would look like this. I've got a bit of pavement on the top, maybe a seal coat, a base coat, a base course, a wearing course, a base course, a sub base, and then some grade underneath all of that kind of stuff. Over here is my curb structure. I've got a little shoulder out here on the side, and then I've got a 3-to-1 fill slope. It could be a cut slope. It could be whatever it needs to be. Okay, so that's just my defined cross section that I may have to create. So those are the things I need at a minimum, but I'm also going to need, when I run this through my RoadNet package, I also need an existing ground surface so we can do this tight. Now, I don't have to have it. It is optional, but you have to declare something so that it has a name. If you have it, then it will find where those slopes intersect that target surface. If you don't, it'll just stop at the end of before where that final slope goes. And it will create all of that 3D line work, as well as generate all of these subgrade conditions, so that it will then look at this cross section all along the length of that roadway at a specified interval and start calculating up the amount of area in those, goes ahead to the next one, computes the average area of all of those things, multiplies it by the distance, the difference in stations, and that's how it computes volumes of roadway materials. Okay, so it does a volumetric computation based on that. So what we need to do is take a look at some of the tools to get there. So let's make a center line. So you may expect that the center line menu has some of those things. So we've already done this a little bit, this polyline to center line file. So if I choose that, I need to give it a name. So I'm just going to call it main well, let's call it, Maple Boulevard. Give it a new name. So now following the prompts, it says, well, it should have been drawn in the direction of increasing stations. Now we're going to start up here at the top and go down to the bottom. We're going to pick that line and it shows you the direction it was created. And so that is correct. If it were reversed, one of my options on the command line is to reverse it. And then I would give it a beginning station. I'll just take the default of 0 + 0, 0, and it goes through a bunch of stuff and then says press enter to continue. And it finishes. All right, so that's great. I've got now an alignment file. Remember our linking, even though it's a polyline, if I double click it, it puts it into the centerline file editor. Notice up here at the top stripe, it says centerline file, blah, 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 Maple Boulevard.cl. Okay. So now again, also with the linking, is if you put in curves, because again, it doesn't, alignments, center lines don't have to be curves. They could be, manhole to manhole. But we want to put some curves in. So you could do these curves a number of ways. You can just do a simple fillet with a CAD command. So if I choose my standard fillet command, I'm going to type R for radius, and let's make this a 500-foot radius. And let's select the first tangent and the second tangent. Now I've put that curve in there. Now to show that linking that works, if I double click that, it puts me in the editor and you can see the curve has been incorporated as part of that centerline file.
I'm sorry, I didn't catch that part of including the curve. I'm sorry about that.
Like that. No, that's all right, like this. So I want to do a fillet on that polyline, which means it's going to fit a curve. So on the edit menu, fillet.
Okay.
All right, so here's my options down here. I'm going to type R for radius. And I'm going to type a value of 500. Right? So now it wants to know, select the first entity. So I'm going to select that first segment and then select the second entity. I'm going to select that middle segment. And when you do that, it takes those two tangents and fits a 500-foot arc in between here. This is where it's tangent to that section and it's tangent to this section. Just like you had drawn a circle at tangent radius, and then you trimmed off your stuff and then you joined them all up together. That's what the fillet command does. So now it has done a simple CAD edit. But if you double click that, you should see this loads up the centerline file editor. And you can see if I go to the curve component and double click it, you can see that, yes, indeed, it was a 500-foot radius curve, tangent to the previous element. There's all kinds of controls and things you can do with it.
Hello, Ken. Mine did not update the centerline file. I mean, it updated what was on screen, but didn't update the centerline.
Okay, all right. So you have this setting. Go to settings, Carlson configure.
Okay.
General settings.
Oh, okay.
Now, here in this object linking,
Yeah, okay.
turn on link line work with center lines. That has to be on when you connect it. Okay. Or when
What was that line work with center line?
Yeah, did you guys not set
Oh,
those?
link line work with center line. Okay, I got it.
Yours is set.
Yeah,
so
because mine,
yeah. So when you double click it, Pete, you go into the editor, right?
yeah, I go into the editor, but it doesn't reflect that 500-foot radius as it does on the screen.
Did you not have that? Was that link line work?
It was not.
It was not. So that's what happened because you didn't have it. So
Okay,
the
let
other-
me just get rid of this arc real quick.
Yeah,
We ju-
can I just update it by just linking it, updating my center line on the screen just with what I already have with the fillet? I already did I did check
Yeah.
it to make
Yeah,
sure.
yeah,
Yeah.
when you have it checked on, then you have to go back and recreate that center line file. Which is
Yeah,
fine.
mine still hasn't,
It won't change it, Pete, if you've already done it once. You turn the linking on, okay?
Okay. Good
And
now.
then do this. So get it
so
back.
what
to-
I did was I erased the 500-foot radius and then basically filled it again with the new 500-foot radius. And you're saying that it won't accept that now?
When you double click it, do you see the curve now in the editor?
Let me just, oh, no, I do, let me just,
And so,
let's
so
see.
you probably should not be able to see it. And the reason is because the linking was not checked on when you created the centerline file.
Oh, I see. So I need, okay,
So just go back to what you're seeing here on the screen now and go back to where we started with centerline, say polyline to centerline file. And you can use that same file name that you did before. It'll just ask you if you want to overwrite it. Well, that's fine. Say yes. You want to replace it, say yes. And now pick that polyline.
okay, so now I'm gonna go back to center line and we're gonna go to polyline. I'm gonna call it this. I'm gonna replace it and we're just gonna select, okay,
All right.
and press enter to continue, done, okay. And
Okay.
now we're gonna,
Now double click your,
okay, so now I'm going to, I double click
and
and
you
I have
should,
my three-legged,
yeah,
and now when I,
and you see that editor, right? That's what I'm,
yeah,
okay, so
yeah.
now just exit that for a minute and come back out. Now let's do the fillet.
now we're going to fill it,
And you're gonna put
radius,
R 500 and pick the incoming and then the outgoing tangent, and it should change it there.
oh yeah, baby, it's there now, thank you.
You bet. Now when you do it, you see it there, right? Okay.
Yeah, oh no, this
I
looks
love-
like it should.
I love you, New York people, when you're happy. So, hey, speaking of which,
Well,
do you, I don't know.
sometimes we're a little slow out of the gate, you know, and
Yeah, that's all right.
but I thank you all, thank
Speaking
you.
of being up that way, we're gonna head up. My wife and I always go up like every couple of years. I don't know, do you know where Shawnee on Delaware is, down at Delaware Water Gap?
I do.
I don't know if you're familiar with that, but it's an old Jackie Gleason era kind of golf resort right on the Delaware River. And it's so cool and so relaxing. So we go there. So we'll be out there in mid-October. So I'll yell across the river at you.
Well, you let me know when. I'll hook up with you, Ken.
All righty. Okay, so right now the plan's the week of the 10th. We'll see.
Dinner's on me.
All righty, we'll see. Maybe we'll see where we can meet up. All right, now, so now that I'm in here, I'll show you how this linking also works. You see how I put that curve in? You see how I can step through these lines in the editor here, and you see it shows up. So go to that next to the last line, this bottom one down here in this spreadsheet kind of stuff. And you see you've got that next to last tangent selected. And come down here to the bottom of these buttons where it says fit curve. And click that button. And where that radius is, let's type 200. All right, so that's going to calculate what that curve would be. And it puts that, now you see it's added that curve. Now keep an eye out here on the drawing, because once you say save and then exit the editor, it's now put that curve in. Okay, everybody see that?
Oh, yeah, looking good.
Now,
Yep.
likewise, all of this stuff can be like, even if you, if you just grip edit these things, let's see, let's make non-tangential. So I'm just sort of grip editing, this polyline. And if I take a look at it, you see it's actually done that. Okay, and I've got a line coming in here and I've got this curve. Now, because I've busted up my tangential business, I'm going to go in here to that curve. I double click the curve, make sure it's tangential to the previous element. And I'll say okay for that. And I'm going to go down to now the line here, double click that, and I'm going to say tangential to the previous element and say okay, and that'll straighten out the tangency. I'll now save and exit. Now I've got fully tangent curves, and that curve is no longer 200 feet. It's now what, 199.9126. Okay. If I wanted to, at this point, I could make it 200 feet, and off we go, save, exit, and now it's there. Now, what happened to all of this stuff? Again, it's just a polyline, but let's go to the inquiry menu and choose drawing inspector on and off. And let's right click and we'll say display curve data. And if we point to that, you see it says there's my radius of 200, arc length of such and such, the chord, the delta, etc. Point to a tangent, it says it's not a curve. It tells you what this segment is. Go back to that first one, there's your 500 footer. Okay. It also tells you, notice that it's on Maple Boulevard.cl. So it knows what centerline file it's attached to. Now I'm going to right click and say turn off the drawing inspector. And now what I want you to do is to select that drawn polyline and those two labels and delete them. And you say, oh my gosh, what are we going to do? Where's our center line? Well, not to worry, because we have that center line file. So we're going to go to the center line menu and draw that center line file. And let's choose this layer. We're going to call it C Road CTLN, C Road Centerline. That's the layer I'm going to put it on. And I'm going to uncheck draw the PI lines. We can figure out where that goes. I will label the center line. So I'm going to hit the set button. And I'm going to look in my Carlson project settings, which should be your default. I'm going to find that CSWCL stations. Or find, one of them. It doesn't really matter. It's just putting in a lot of the defaults for us. And we're going to choose our Maple Boulevard and choose open. And now look what we've done. Out of nothing, we were able to create that center line. And there's ticks and radius values and PC labels and all that kind of stuff. Now I can see that this is probably a little bit. Let's make this a 100 scale drawing. So I went back to my drawing, my settings menu, a drawing setup. I changed it from, I forgot what it was, in 40 or something. I made it 100 with my 100 scale, because this is really a large site. And then when that's all I did was change that scale, but I went over here to my LT scale and I set that to 1 because that part of it is not linked correctly. Right? So that's all well and good, but I need to recreate these things to get the proper size that I want. So I'm just going to go back to centerline and do it again. Draw the centerline file. So when I do that, label the centerline. And maybe I choose to, use a different labeling style. And don't worry about that. None of that matters. But you can see what it did is I've I've shortened these up. I've taken off, made the letters are bigger, or the text is bigger. And I'm just going to pull this back this way a little bit. And again, because it's just text, it doesn't matter. All right. So that gives you an idea of doing some things with the center line. And there they are. Now, we haven't done a road. All we've done is the center line. It's down at 0 elevation. We don't have any idea where it is, where it goes. So I'm going to now go back to view and say fall/on all layers. So I turn my contours back on so I can sort of get a visual reference as to where I am on the ground, so we see what happens with this. And let's start to design this thing vertically. So that's my profile. So I need to go to the profile menu, and I'm going to design a road profile. Well, the way you design a road profile is a couple of ways. You could say create a profile from a grid or triangulation surface, and that would be you walk along the center line and you sample that surface and you create a profile. So we need to have done that from that as an existing ground. That would be our existing profile. And then we would say design a profile. We would create, then we would design, go to our profile editor, and we would put in a file name and start to edit up our road profile, and we would load in that existing ground profile as a reference to look at. So all of those things are there. We're not going to go through all the separate items, but see, there's this profile editor. Once it's here, you can, let's just give it a, let's give this one just a name called Junk. I want to show you that this is the editor, and it's going to put in, right now it starts with nothing. You got profile types down here, just a generic one. You've got a road profile. Notice the headings on these columns will change based on what kind of profiles you're talking about. Okay, so those are individual ones that you can sort of do, sort of without a specific purpose, or maybe doing profiles of non-roads. And I think if I'm in survey, I'm switching real quick. I'm not sure. Go to my profile. Yeah, so if all I have is survey, then I have to use the profile editor and do it that way and change it to the different types. But if I have civil, I have under the profile menu, I've got not just those items, but I've got this specifically for road design road profile. And it goes to a road profile editor, which is, it's going to give us a lot of those controls that we would have to pick out individually using those other editors. It's the same editor, but it's just going to have more controls in it. So now we have that center line called Maple Boulevard. Might as well call this one Maple Boulevard as well. And this is my design. I'm on the new tab. I'm in my data set. I choose open, and now it goes back to immediately asking for a file. Well, look up here at the top stripe. It says, all right, give me the center line, because I know when I do a profile, I have to be following a center line alignment. And right there's our Maple Boulevard. We choose that and say open. And it keeps asking me for information. Well, what is it asking me for here? It wants to know a terrain model, an existing ground model, so that it knows where to tie the road down and how deep it's going to make cuts and how deep to make fills and that sort of stuff. Well, there's the one in our project area. We'll use that. We'll say open. And then finally, it's going to pop up into this editor. Okay. And you can see as you track along in the editor up here. There's a marker in the plan view, and you can see, how that's going to work. Let me sort of put this off to the side a little bit and go back to that road profile editor.
Excuse me, Ken?
Yep.
I'm sorry, I don't mean to interrupt.
Go ahead.
I may have missed something. We had the center line, it's all labeled. And then we were gonna jump over to profile editor, is that correct? Or we have to design a road profile?
Design a road profile.
So we're gonna go to profile. And we're going to design a road profile, and then what? We're just gonna go to road profile editor?
Correct.
Road profile editor, and then we're gonna say road profile editor. Okay, and then we're just gonna say existing, which is fine,
Mhm.
and fine. And
Yeah, you have to tell it the center line, and you have to tell it the,
or the surface is at, it says here the surface is out of range, what?
yeah, you have to find the center line. It'll ask you for 3 files, one for the file of profile, the other for the center line, and then the third.
It asks for the profile.
Yeah.
It asks for the center line.
Yeah,
Asks for the surface file.
right. That's where you use that phase 6 original, or whatever it's called.
Right, we're just gonna hold that. It's defaulting to something, okay. Oh, and then it says the surface is out of range.
Oh,
What does that mean?
well, I don't know. Let me save this and exit. Let me come back to it. Share your,
Oh, share, here.
Yeah. let me take a look.
Oh, here we go. Is this, oh, here it is, here it is. Oh, I need to put this on the other screen.
Or share that screen instead, either one.
Oh, I could just do that? Okay, let me
Yeah.
just turn this off. And, oh, here we go. How the heck did we do this? Oh, and then we're gonna share.
Yeah.
Oh, there you go.
Okay.
Is it, is it visible?
Yep. So now let me where are my controls? Here we go. I'm gonna request remote control just in case.
Okay, approve.
All right. So now go ahead and exit that. So we're gonna exit the editor and not save the changes. Let's go through what we need to have here. So I've got a centerline file
Right.
labeled, and we've got this these contours drawn, everything's good there. So so what we're going to do now is, I can get the mouse to avoid it. Slowing down. All right, so if I go to my profile menu and choose design road profile editor. So I'm going to go to a new file here, and what did you call your center line?
What I called it was just today's date,
Oh, okay, so I'm going to
09/09/22.
I'll keep the same name. All right, so now it wants to know the center line file. There it is.
Yeah.
Now it wants to know a surface file, which is that one there. And I say open, and it says the surface is out of range. And why does it say that?
I mean,
There was that phase you missed, Ken. It did show that phase 610 as an option when you got to it.
Oh, where did the,
I'm not sure, I'm not sure if he's got a different surface.
No, that's perfectly exactly right, I think, because I think that 09 surface is not correct. So I'm gonna use
I'm
that.
not sure, I mean, unless there's a surface that came with that drawing, I did not.
There is right here. Phase 6.
Okay,
Yeah, there it is. All right. There we go. Perfect.
there you go.
Okay,
I
so
kind of
yeah,
suspected as much.
that was the surface that was included in the DWG that we're going to, you know, that when we did the import civil 3D data, it took care of
Right.
it. Okay, all right. So I'm going to
Stop sharing.
stop. I'll take care of that part. Then I'll,
All right, thank you, Ken.
back
Thank
here.
you.
You bet, you bet. So we'll share back to this. And so you guys see my screen again?
Oh, there it
Yeah.
is.
Yeah,
Yep.
okay. So profiles, design road profile editor. Now this is an existing file now because I did it earlier and I saved it. But I didn't have anything in it, just a straight line. So what it's doing here is it starts over here where the alignment starts at 0, 0. And it puts a point, an elevation point down on the ground. Okay, so it's elevation of 80.8372. And it goes all the way to the end of the alignment and puts a point down on the ground at 99.1503, which it's really, this number should technically be 0. You saw it was rounded off just a little bit. No problem. I just made it 0. It doesn't hurt a thing. All right. But now we got a couple of things to notice here in our editor. I've got some green triangles. And if you see where when I hover the mouse and I get the tracker on that one, then I go to the next one up here, look in the plan view and see what I'm corresponding with. Those are my PCs and PTs, right? See them?
Yeah, I
Yes,
don't, I
sir.
don't have these triangles.
Okay, if you don't have the triangles, and I'm going to show you those things, I'm going to go to setup, this button at the bottom that says setup.
Yep.
And you're going to check right over here where it says show centerline special stations. Check that on and hit OK. Now you should see those triangles.
Yes.
Got them? Okay.
Yes.
Now there's several things that you can do in there. You can turn those on and off. You can, you know, they could be in your way. One of the reasons you want them on there is because the design guidelines for proper road design, according to the AASHTO Green Book, you know, the American Association of State Highway and Transportation Officials, is that you should never have a vertical curve within the bounds of a horizontal curve, because you run the risk of making a broken sight line. You could have what's called a broke back curve where you can't see through the entire length of that curve. So that's just good guidelines. Now, that being said, sometimes like if you're out in, you know, Western Pennsylvania or up in the Adirondacks or out in Colorado somewhere, sometimes you can't help it. So if you're not all that overly concerned about it, and if all your buildings a subdivision drive through, then it's not that big a deal. But that's why you want to have that. Now go back to the setup button and you can see a couple of other things. You could turn on the show reference surface. Now the reference surface is this red line, that's existing ground. And you can see as when you're tracking, you'll see that blue crosshair. You see where it crosses these two little peaks. So if we show the reference surface at left and maybe right offsets, 15 feet left and right, say 12-foot lanes and a 3-foot, well, let's make it 20 feet. Left and right. And if you want to do that and say, okay, now you see this. So you can look in here at this station and the uphill side of that. So my yellow is my right-hand side. My blue, my light blue is the left-hand side. The red is along the center line. Okay. I get up to this area and now the yellow you see is lower than the center line, but the blue is higher now. So they've traded places. So that just gives you an idea of what the cross slope might look like. I'm going to turn those things off. I'm going to turn off my show reference surface at left and right offset. I'm going to turn off show centerline stations. Now there's another one here that says show vertical lines for intersections. Leave that on and we'll see that when we get to it. Because if you have a road that intersects this, and if you're using RoadNet, you'll see those intersections and it'll be marked with a vertical line. Okay. Now we're going to output this reference surface.
Question.
Yes.
Yeah. So the red there, the red line is actually showing the profile on this surface, right?
The existing ground. Yes, that's my reference surface.
Okay. So where is our profile then?
We haven't built it yet. The only thing we've done right now, we've got a PI here at the start with 0 depth. We've got a PI at the end with 0 depth. We haven't put any curves in it yet.
Okay. Sounds
So
good.
we're looking at that white line. That's going to be our profile. So right now, if we graded this as a profile, it is a profile. We just start at that elevation and just climb up the hill to this elevation. Well, we've got 2 mountains to move, right? So we don't want to do that.
Okay.
All right. So,
yeah.
So what we're going to do is we're going to add in some PVIs, point of vertical intersection. Now you can do that a number of ways. If you Will, you may have this a lot. You may be looking at your design plans and you'll see, you know, the station of the PVI. You'll look at the profiles in the drawings and you'll see the PVI station. You're just going to type those values here, type its elevation, maybe its vertical curve length. It will calculate all this other stuff and you can put these all in by text. Okay. So that'll help you to build those things. Just go right straight to this editor and start building those things in here. Just come down here and insert and add as you go along. Okay. But we're going to do this graphically. So we're going to use some of these tools up here, and I've got add PVI, shows a plus on it, and I'm just hovering the mouse right now. And then the this one next to it has a pencil on it that says edit the PVI. So that's really what I want to be doing. So I'm going to add a PVI. So I'm going to choose that, and now everything sort of dims out and it tells me to add a PVI. So I'm going to go up here and sort of near the crest of those two hills, I'm going to click the mouse left button, click, and this box pops up. And it says, okay, well, you clicked near station 835, and that's what the elevation is. That's my incoming outgoing slope. And if I were to do this right now without specifying a vertical curve, it would be just it meeting a peak. So I want to give that a vertical curve, let's say of 150 feet. And that gives me, 94 feet of sight distance. And then I've got these values here. I can make it snap to the nearest 5-foot station and the nearest half-foot slope in and out. And I'll say, okay. And there it is. Now, well, so that's right in there between those two peaks. Well, maybe I say, well, I've really got a lot more room. I don't need to make that quite so severe. Well, maybe I'll just come down here where it says this, what was originally 150 feet. I'm just going to double click that down here. Let's make that a 300 foot. So you see what it's done is it's made the vertical curve further. I've got more sight distance. So I can move things along. All right. So I'm going to add another. So I'm going to go back and grab my add PVI, and I'm just going to come down here and click near this low spot in there. And let's make that one say 200 feet. So far, so
I'm doing the same thing as you, but I'm not getting that little pop-up window.
when you click this, when you click that add button, move the mouse up here, but don't do anything with the buttons, just hover. And then when you get over near where you want to do it, click the left mouse button. That should bring this up.
Okay, I don't get it, but I got it now. Thank you.
You got it?
Yep, I do. Thank you.
Okay, doke. All right, so I've now put in 3 vertical curves. And you can see a couple of things on there. I'll let you, it shows you the crest information on that one. And you can see here, there's my 200 foot, my 300 foot, my 150. And as I go through these, you can see, what's my sight distance. You can change that to K value and all that. But we're going to just take this as it is. I'm sort of along the ground. I'm really going to have a lot of cut through here because this is a really goofy existing terrain, to be honest with you. Okay, so let's just hit save and exit as long as you've got something that looks like that. Now, you don't need to do this part, but if you go to the profile menu and choose profile to 3D polyline, and doesn't matter what layer, we're going to erase it. I just want to show you what we've created and where it is. I'm going to say okay. No, wait a minute, sorry, wrong thing. I want to draw. I didn't want to draw the profile. Let's draw the profile file. I want to create a 3D polyline from the profile information. Let's see. Profile 3D polyline should.
Is it create profile from in at the top?
No. We've already created the profile. We've got it in the editor. See, there's my profile. I want to, well, anyway, I was just going to show if I create that. That profile to a 3D polyline converts a 2D centerline into a 3D that follows the elevation of the profile. All right, that's what I want to do. Profile to 3D poly. Okay. Polyline should have been drawn in a direction. Oh, okay. So it's not. All right. Sorry about that. So if I type CL as one of my options for a centerline file, I'm going to choose that centerline file. Okay. Now I'm going to read the profile file, and it just drew it. Okay. And so what that's going to look like is this in your 3D viewer. So you can see that see how it rises and falls based on where it is on those profiles. And if I look at that in my 3D viewer, try to see, that's sort of like the way you saw it in the profile editor. We're sort of looking at it from the left edge.
Yeah, Ken, I wasn't able to get to that part where you take your profile, where you create your profile from the 3D polyline from the profile.
Yeah, I'm going to say don't worry about it because let's see, hold on a quick second on the SLT scale. There we go. And there we go. Yeah, I was just, the only reason I showed you that was that I just wanted to show you that it can actually create that three-dimensional edge, but we're going to use something else to generate that for us. Okay. And what we're going to use is the road processing tools. All right, so now that I've seen, you know, how all that lines up over top of those contour lines, I'm going to go back to freeze them off just to get a little more visual clarity. I don't want to keep, you know, trying to stumble over everything. So now you've got a center line, you've got a profile, and what else do you need? Well, we need a cross section, which is actually a template. But if you look on the sections menu, you might think that's where you design your cross section, but this is not. This is where it actually goes through the cross section editor as it steps along an alignment. It can be anything, doesn't have to be a road. It can just be a bunch of cross sections. So I'm going to go to roads. The roads menu now is where we're going to do this design template. And so I'm going to choose that command, and it says, now give me a template file that I want to edit or create. Well, if I say I want, let's choose this existing tab, and let's look at this one called test.tpl, and we'll say open. Okay. So when I look at this, I see an editor here that I've got, you know, some lanes, some curbs, this buffer area, sidewalk area, and then a slope start, another buffer area. So you can see those three things, buffer, sidewalk, slope start, and then you've got these cut and fill values. I've got my little checkbox on for the right side, same as left, to mean that anything I put over here, it's going to also be on this side over here. And I've got on my fill side, if I click my fill button, it's just a simple 3-to-1 fill, and it's going to tie down to the existing ground at a 3-to-1. If I look at my cut side, I see that it's also a 3-to-1 slope, but I'm putting in these little ditch grades, and you'll see what those are in just a second when I come back out and I look at that. There's your little ditch. So it goes over here, and instead of starting up at 3-to-1 here, it builds in a ditch before it goes up. Okay. And that's defined by that cut button here, where I put in a grade that is at a -1-to-1, because I'm at ratio, not percent or vertical. So a -1-to-1 for a distance of 1 foot. And it goes down to a point that I call ditch bottom. Okay. And then I come to this next one, and it goes at a +1-to-1 slope for 1 foot and makes a point called ditch top. Right. So that is, you know, 1-to-1 down for a foot, 1-to-1 up for a foot. That's my 1 foot deep, 2 foot wide at the top ditch. And then my slope starts up here. And so now that doesn't mean that it's always fill on this side of the road and always, or cut and always fill on this side of the road. That's just showing you, you know, like you might, well, let's say I don't have any super elevation, but you know, you might have them not show you any, or you know, they're both in cut or both in fill. So it could be anything you want, but what you typically do in this editor is you do one side one way, the other side the other way, just to show you that if it is in fill at this location, this is what it would look like. And it goes down until it hits the existing ground. Over here, it goes up until it hits the existing ground. Now that same thing might happen over here. It might go this way. It also might be fill over there. We don't know till we process this whole project. Okay. Now there's nothing underneath yet. Okay. So let's take a look at what we got. So let's save this editor, and let's see, that's just called test.tpl. So let's save as, and we'll call it just like the other, Maple Boulevard. And we'll say exit. Now, we have now the 4 things we need. We have a center line, we have a profile, we have a design template, and we have a target roadway surface. We haven't designed the thickness of the road yet, but our road does at least have curves. So let's see what happens when we process this. So let's go to the roads menu and come down here and say process road design. Now this is a little thing that it's a little control box that brings up a series of buttons on the left and then edit buttons on the right. And these are some input files, some output files, and this is going to be what happens when we hit the go button. So right now the center line, it was the last one we used, Maple Boulevard CL, with the edit button. The design profile, I'm going to click that button over there and choose my Maple Boulevard. So that's now set to that. And my template series, I'm going to set that to my Maple Boulevard as well. So I now have those 3 things. I don't have an existing surface defined yet in here. I've got the file. So I just click that button. I choose my phase 6 original. There it is. And now notice if you hit the edit button, there's my editor for the profile. If I hit the edit on the center line, it takes me to my center line editor. If I hit the edit on the template, there's that one. And the edit button for that ground surface, I'm not sure what that's going to do. It's going to bring into that triangulation file utilities that we saw where we did things like add, multiply, subtract. So that loads that up for us. Okay. So we've got everything we need. We're good to go. We're not putting out any kind of outputs. Let's do cross section. So I take that first one, design section, and we'll call it Maple Boulevard. Existing section, I'm going to call Maple Boulevard -EX. And that will be all I need to worry about at this point. There'll be new files. I'll say okay. Now, when you say okay, it needs to know how to handle it. What range of stations? You got some settings where you want particular setting or particular template drops or cross section that it's going to create. You can cut and fill gaps. Let's say you're going across here and you've got cut and fill and then you hit a bridge. Well, you don't want cut and fill off the edges of the bridge. So you can put gaps in there to turn those on and off. Okay. The station interval, I'm going to set to every, not 5 feet, but let's go this every 50 feet. My existing cross section, how far out do I want to see to check? Now I can
Excuse me, Ken.
Yeah.
Did you have to create a new additional road design parameter file, or you just a new new parameter design for the design, or did you just start a new file?
All right, so I went to roads, process road design.
No, I'm saying where you have this, because right now we're currently at the road design parameter tab.
This?
Yeah.
Yeah, that's where I was.
Okay.
Did what, no, is it missing?
No, I'm saying I have everything in the design files, and so I was just following what you're doing, and I got to the part where it says road design parameter, but I thought that's what you selected to get to this.
Oh,
Uh,
no, I just did, I had this and I hit okay. And when I hit,
Okay.
when I hit okay, this comes up,
Oh, okay.
okay? All
Yep.
right. All right, so now, and you can, you can tell it to only work at a certain range of stations, and we're just gonna take the full range. And let's set our station interval to every 50 feet. And our existing cross-section maximum offset, let's make that 150 feet. Just because we got such a huge site, I don't know. So it's gonna look at 150 feet each direction from our road to make sure it catches the ground. And now the template ID for profile, right now it says center. Go ahead and leave that like it is. Take all of these other defaults. And when it comes down here to the middle part where it says triangulate and contour, uncheck that for right now. And then let's come down here and turn on erase previous road entities. And let's draw the disturbed area. And let's draw the template polylines. And I'll explain what those mean here in just a minute. So let's say, okay. And it's going to process, and it's going to give us a little report here that says, here's our template file, the profile file, the surface, etc. And so it's going for that station range. There's how much total cut, 42 million yards of cut, 2 million yards of fill. That's a heck of a job, isn't it? How much disturbed area, not a whole lot of disturbed area. And here's my curb, 1,700 cubic feet or 64 yards of concrete for 1,500 feet left and right, because it was both basically the same length the whole way around. Okay. So, and if we had the subgrades defined in our template, which you'll see in a minute, then we could see those materials defined as well. Right. Now, what happened? What did it create? If I look at this now in my 3D viewer, I see the edges of where the cut and fill banks would hit the existing ground. And I see, oh, look there, there's a ditch on that side. Can you see that business? And I see the curb lines. In fact, maybe a better way of looking at that might be, let's go to profiles, quick profiles, and choose screen entities. And let's go from here across to here. And now you can see that same shape that we had coming there across our sidewalk and down here and up. And there's our ditch right there. And finally up to this other road. So it generates those lines. And if I look at, that's on a layer called road break line. And it looks like they're all on layer called road break line. You have control over all that. You can set those up to be on their own named layers based on, what template point they are. Okay. So I'm going to go to edit, erase by layer. And I'm going to pick one of the boundaries, road break line and perimeter. And I need to get rid of these two as well, just to clear the decks. All right. So going back to roads now, to process road design, I've created these cross-section files. They're already there. They've been created as part of running that process. So when I said, okay, and it's down in here's where we control things like, let's see, we got what occurs horizontal offset of the road. Oh, this template ID, the center. And I'll show you where those come from and what they mean. But here's where you set your layers. For instance, the tie down, the subgrade break line, the perimeter, that's the disturbed area. Okay, and so you can, the template polyline layer is road break line, or you could say use road or use grade name for a suffix. And let's go ahead and turn that on and let's say, okay. And we'll say okay to that. Now, when that comes back, we get the same report. We haven't made any changes and it drew the same lines. But I'm going to go now and look at my layers just so you can see what we just created. We now have road break line buff, road break line center, curb, curb 3, curb R, curb 2, curb 3. So these are all different ones. So I'm going to turn all of these curb layers a particular color. I'm going to make those cyan. I'm going to make my buffers sort of this brownish looking color. I'll make my center line. Yeah, let's make it red. And what do I have here? My ditch bottom, my bottom of my ditch, I'm going to make a dark green. The top of my ditch, I'm going to make a lighter green, say that color. And let's, what else we got? We've got break line, edge of pavement. Well, let's make our edge of pavement line sort of this dark gray. My start of my slope, I choose that 104. The sidewalk, I'm going to make it yellow. And my tie down will be white. So I think that'll be okay. I'll save those. And so now you can see, I can see those structures a little bit more clearly because I had predefined the colors. So if I zoom in here, and so now I see there's that road. The edge of pavement is that gray, and I see those two, or three actually, light blue lines for my curb. Okay. Here's my center line. So it has created every bit of that stuff in 3 dimensions. Now, what can you do with that? Well, you can build a surface out of that if you wanted, just like we've been doing, triangulate and contour, and then we would gather up all our stuff and, you know, try to make sure we do it. But the road design stuff has that built in. So let's go back to the roads menu and go down here to process road design. And this time when we say, okay, let's do a change up here. We're going to turn on triangulate and contour. And we're going to hit the set button. And so that's going to bring up a box that should be somewhat familiar to you. Just like when we did triangulate contour before, it no longer has a selection tab. And some of these are different. So on triangulate now, instead of all of those different options down here, we don't need to worry about them because it's not using variable input stuff. It's creating its own. So, but I do want to write the triangulation file. So I've got that checked on and I'm going to hit the select button. And I'm going to call this one Maple Boulevard Surf. Okay. So that's going to create a file that we can look at and take care of and, you know, that sort of thing. I'll go to contours. And this time I'm going to turn on to draw my contours. And, well, I'll take these contour layer. I'm going to put it as road dash CTR, and I'm going to set my contour interval to 5. And then I've got draw index contours is checked on, and I'm going to put down a layer road dash CTR INDEX. No smoothing. Don't need that reduced vertices. I'm going to go to the labels tab, and I'm going to uncheck that. I don't need to see those for now. And I'll say okay. And I'll say okay. So now it's going to come about, give me that same report in terms of the quantities, but I didn't do anything to the design. So it's the exact same design. The only thing I said to do was create a surface file and draw the contours. Now I also saved the file. So if I want to now go to my let's see where these are those two, the existing contours. So I thaw those layers, and you can see now where this, say this contour, that's my intermediate contour, and you see it comes down and it ties, I mean, not intermediate, but index, and it ties right onto this one, okay? Same thing as, you know, any of these, you're going to see when they come up, they're going to go across the road and they're going to tie in exactly where they need to tie to match that existing ground, okay? So that was one of the options when we did our roadway stuff, was to, you know, trim the contours inside this line, so we could have trimmed out those drawn contours. So we'll come back to that in a second, but what I wanted to show you here too in this design template, when you edit each of these things, now we'll come back to this, you know, when we start adding our subgrades. But you see when I double click that and I edit this and I tell it I'm going to use a horizontal distance of 12 feet. This right here, this EP, that's my edge of pavement. So that's a name that I give that point. So it starts in the center. There's that first one right there in the center. And it goes, you know, it goes, because right side same as left. It's going to go out for 12 feet at a minus 2.08% and set a point called EP. Then it's going to create this curve. And you do those by clicking that curve button up there or double clicking. And you fill out all that information in here. You give it a material called concrete, and there's the ID name called CURB. Then I go to this next one. So I've come out to the EP, I've come out to the back of the curb, and then I added another grade and I called it BUF for buffer. Added another grade here called SW for sidewalk, and that means that point right there is my SW point. And then I had one more, which I called SLP STRT, standing for slope start. Okay. So that's what I generate. And those names, EP, curb, buff, SW, SLP, STRT, as well as DTCH, BTN, DTCH, TFP, those are all points that are named in this template. And that's the answer here when I say okay, and it says, what template ID do you want to use to set the elevations based on the profile? Well, center was the center, so that, you know, but sometimes your profile designs might not be the center line. It might be the, you know, the right edge of pavement governed by that profile, and everything else falls, you know, as offsets away from that. So you could actually have typed in here, say EP for edge of pavement or something along those lines. All right. But now we've done these, we've set our layers, set our slopes, we've got triangulating contour. You could merge the road with existing, or you just say, okay. Oh, shoot, something I meant to do, missed it. I'll just repeat it. So what I wanted to do was in this triangulating contour right here in the middle, I'm going to hit set. And on the triangulate tab, I'm going to check trim existing contours inside disturbed area. Now, I'm not sure it's going to recognize those. It might. So when I say, okay, let's see what happens. Retain the trim segments, no. So yeah, it cleared them out. So now you can see when it draws those, you see the contours are lining up. Now they're not, we're not going to crisscross them. So I'll take these, take these boundaries and we're to turn them off. So there's your design line, your design road design. Look at that in 3D. And now you can see, you can see this as the drawn three-dimensional line work that it created. But again, all this is just drawn lines, but you can see the ditch there. So let's go to our model tab and I'm going to add that Maple Boulevard surface. And wow, look at that. There's a set of colors. And they're all different colors. So our curbs has that little cyan, the road's sort of dark gray. There's my buffer, there's my sidewalk buffer. And so, you can establish all that. And that's just a simple file. And you can see the ditch. There's their cut slopes. There's fill slopes. You see all along the cut slopes, you see that ditch that got created. Okay. Now, if you didn't want those contours trimmed off inside of those, you would have, we've trimmed them off and thrown them away. Let's say we wanted them back because we want to show just an existing contour map. And if we do that, how are we going to do that? Well, remember we got all that stuff from a surface file. So I'm going to go back here. I'm going to erase by layer. I'm going to choose clear. Select the layers from the screen. I'll select one of those, which is C topo major, C topo minor. And because it came from a file, I'm going to go to my surface menu and I'm going to say contour from a tin file. I'll choose my phase 6 original ground. I'm going to draw my contours. See topo minor, major, 5 is my interval. Draw the index contours. I'm going to label them this time. Hide the drawing under the labels, align with the contour. And let's go a distance of, say, 1,000 feet. So now that's going to come back once it finishes. See, it's down here. There we go. So there's now, that 1,000 feet from here to Here, I must have said 100 instead of 1,000. All right, so back to contour from a tin file. Yeah, there it is, 1,000.
What time is it?
Yes,
No, sorry, I'm talking to myself.
oh, that's all right. So there was C topo minor. Oh, it should be V. So C topo major. All right, so now play those off and try one more time here. Now let's go to contour from our file, original ground. And let's change this layer from C label to C topo major so it'll match the color. And that's so okay. Topo minor IC topo. Wow. That's similar. Topo there it is, so better what I wanted. Except yeah, they're all showing, they're all labeled instead of just the index ones, but no worries. So now that's how I could put those back at any point, and I could even, without having to rerun the roads, I would just go to surface, contour from tin file, find my road this time as a surface, open that, and where it says erase previous contour entities, this time I'm going to turn that off because I don't want to have it erase these. I'm going to just add to it. I go to contour this time, except I'm going to select C-road. Wherever we had it, C-road. C topo. Oh, there it is. I think road. What to do? I don't see it. C road. Maybe minus Spain section. Surface C road. Should be where we know. Yeah, let me verify here what that was. Oh, RD dash. So now surface contour from and file the roadway, and that's going to go on. This will be on under index labels. I'm not going to label. Yeah, so there, I've got my grading plan. Okay. Now, remember when we ran this Austin road design, we had some optional output files down here that we said, let's output and look at the design section and the existing section. So they got created. We haven't seen them yet. So I'm going to go to my sections menu. And I'm going to go to my, let me either draw the file. Let's go to our sections editor, section file editor right here. At the end of the second block of commands. And it wants to know a section file to process. Well, the one I'm going to process, I'll choose the Maple Boulevard EX. Okay, so that's going to be, whoops, let me do this. Section file editor, let's use Maple Boulevard. Okay, and now it wants to know a reference section. That should be the EX one. So I'm going to edit that as EX. I've got the reference center line, so it needs a center line to walk along to show you those cross sections every 25 feet. Now I can go to any given specific station. Let's start at the beginning. And there's what it looks like there. I can go to, if I drag a little slider, you can see as I walk along the road, station by station, that's what has to happen to make that road fit our design. But look also at you know, what some of these things are. Here's my descriptions. That's what I'm saying. So any given station, I'll be right here at this station. So starting on the left, I've got my tie point. Here's my ditch top, a ditch bottom, slope start, sidewalk, buffer. Now this is where the curb points all come into play. So I've got a curb 4, curb 3, curb 2, curb 1, which is, and then back to curb, which is the back part of it. And then curb 3 is the top face, and curb 2 is the flow line there. And then finally, edge of pavement. Okay. And then center, there's the center of that. And then it just mirrors that on the other side. If we have a particular station that is part, yeah, here we go. So one that's part and cut, part and fill, you're going to get those there. Now you can, you know, use the slider. You can make edits to all those different things. You can type in a specific station, even if it's one you don't have. You see there's one at 0 + 0, 0, and the next one up is 0 + 50. So let's go to say 6 + 0, 0. The next one up is 6 + 50. So watch what happens here. If I go to 6 + 0, 0, and if I want to go to 6 + 20 instead of 6 + 50. I can't actually do it here. One quick second. If I say here, yeah, I need to add. Yeah, there's 6 to 650. So I can interpolate, and I want to interpolate 6, say station, and go ahead and interpolate that, exit that, and now I've got this 6, and now 6 + 25. it interpolated. Except I didn't, I didn't do one thing. So 625. That's what I need to use for the interpolation. So the reference profile is there. Web statement exists. Yeah, I know. Fine. All right. So anyway, the point of this is you can edit this roadway any number of different ways through those cross sections, and you can save those changes, and then recreate the road. But all of that stuff is well and good, but you need to, you know, you want something to create those material depths in the road. We've got the curb, but all of that's governed in that design template. Now, that was done in this process roads design. That used to be all we used to have. And there's, by the way, after you've made changes to the design, the cross section, you can reprocess it. Right. So let's take a look at the next step up, and that is doing this as a road network. So I'm going to go to the roads menu. I'm going to pull it down, and instead of process road design, I'm going to go to roads network. And I'm going to choose new. And let's see, do I have an existing? No. So I'm going to say new. And I'm going to call this one, you know, Forest Hills, since I've got a Maple Boulevard. All right. Now, my road network is sort of like that process road design that lets us choose a bunch of files. We got edit buttons, chooser buttons, outputs, and hit the go button and off it goes. But it's one better than that. It not only can do a roadway, a single roadway, it can do an entire network of roads. So I could have an entire subdivision plan with intersecting streets and all kinds of things going on. And then if I say, you know, change the profile of one of my roads and I've got streets that cross it, well, it's going to pick that crossing street up and carry it with it because it knows it needs to cross at the same elevation or push it down or what have you. Now, if it doesn't, let's say it goes under a bridge or an underpass or something, then you simply don't add that street into the road network. You let it float free. But we do all that. We've got some settings. We've got a number of things to file. This, you know, this is sort of a lengthy thing to get into. So we're going to have to zip through it here pretty quickly. So I'm going to get to a couple of grading issues. But if we have to add roads, and then it finds intersections and does the computation for it. So I'm going to choose the add button. And it says, oh, existing surface is not set. Please specify the surface file. Okay, that's fine. And it's going to be my phase 6 original ground. There it is. All right. So now it wants me to add a road by centerline file or by screen picking a polyline. I'm going to choose by centerline file. I've already made it. So there it is. It's reading the numbers. And it wants to know a design profile. And we already designed that one. So we'll use that. And now this is sort of like that same thing you just saw, where we've got buttons here to choose, edit buttons over here, and here's my template. So if I pick that and I choose that Maple Boulevard template, it's now there. I can edit. I've got all of these same type of controls. But now these are my required input files. Those are the very basic ones that I have for any given road. Then I've got some optional input files down here where I can establish super elevation, where I bank the road around curves. I've got topsoils. I've got road striping. So this gets into some really deep and complex things. Template transition. So I may have a 2-lane road, and then I'm going to go into a, as I approach an intersection, maybe I'm going to put a turning lane in. So I'm going to now go to a 3-lane template. And so I need to put in a transition from the 2-lane to the 3-lane. It lets me do that. And I've got all kinds of different things that I can use to modify those. And down here are these, there's that optional output files for the existing section, the final section, any rock, any existing profile file, etc. So these are already sort of preset, and I'm going to make sure my processing on is checked. Okay. And I'm going to simply say, okay. Okay, so now that part's established, and when I select that road that I've added, I double click it, I look, if I make any changes, and I'll say, okay, and what's, oh, okay, so here's where I make edits, changes to my templates if I want, or center lines my profile. So I don't need, I'm not gonna make any changes there, but I'm not really outputting anything yet. I haven't really designed anything. In fact, let me edit erase by layer. I'm gonna get rid of these. Contours, and then why did we do it? Let's see, get my layer. I've got this. I want to. There we go. So those are good out. All right. So now I'm just back down to basically nothing there. I'm going to on my road network again. It keeps that up here. I can change that. But let's look at some of my settings. I'm going to hit my gear button, and I'm going to, that's where I've already established the existing ground. I don't have a rock surface. I'm going to go to a 25-foot station drop. And if I'm in an intersection, go every 5 feet, existing section, maximum offset. Now process on updated design files. So you could have it, if you make changes, you can either automatically reprocess, or you can always leave it off, or I'm going to leave it at prompt so it can tell me I can decide if I want to or not. I'm going to tie to existing. I'll process any intersections, connect my roads. My output options now, I want to triangulate and contour. And this is why you didn't see anything. It's because you didn't, we hadn't set this up yet. So if we triangulate and contour, now hit setup. I'm going to, just like before, I'm going to write the triangulation file, and I'm going to use that Maple Boulevard surface just like I did before. It's an existing file, that's no problem. And I'm going to choose this set colors and layers, and this is where those colors in that surface file came from. If it creates an EP, make those colors this dark gray. If it creates a curb structure, make it that color. There's my buffer, there's my sidewalk. So basically my curbs and sidewalks are cyan. And those other two things around it are this sort of buff colored. My ditch is going to be green. And I've got this thing called other, which really I'm going to set that to be sort of a darker green. And then I'll set that also the same color. And the color style is going to be by grade ID. And that should take care of what we need. We will draw these contours and let's set some C dash. Put that in, there we go. Minor. Oh, there's road. There we go. Minor dash RD. Actually, let's just put those back where they used to be. Okay, no labels. I'm just going to draw them. No smoothing. We're drawing the contours. We are creating that file. And we say, okay, yep, okay, right. And now a couple of other things that we can do. What surface do we want to draw? All right, here's a merge row. We haven't set the file name yet. So we're going to call it Forest Hills Merged. Now, which surface to draw? The road only or the merged surface? So I'm going to draw the road only. So it's going to draw those contours. And some of these options down here, you can kick out coordinate points, make Carlson points, and do things like look along all of the EPs, all the edges of pavement on both sides, draw the points, give it a name, and say maybe put profile low stations. So if you've got we don't have any, all of our profiles are entirely either crest curves or they're bottom down type curves, like a sag curve would be, but it's not actually a sag curve. There's still positive grades going in and out of those. So you wouldn't see any there in that case unless you had a curve that was too low. But anyway, you could have it flag any of those low stations along the profiles, create points, and then you just look and decide, well, that's where I need to put my stormwater inlets, my catch basins. So it finds those low points and puts them in there. That's one of the uses for that. Okay. So I'm going to just turn that off though for now. That should be good. Reporting. Report cut and fill end areas, cut and fill differences, subgrade topsoil, cumulative cut and fill. Set my precision, my display options. Highlight, and that means when I select over here, it's going to highlight where it is in plan view, and you can either have it thicken or go dashed or do neither. So I'll make it thicken. And the same thing for intersections and cul-de-sacs, whether it just puts an arrow pointer or it's going to draw a circle around it. I like that part. I'm going to go to my defaults, and for now, let's leave these as they are. That should be okay for us. All right, now we'll say okay. And I'm going to go over here now to my controls. I'm going to hit that little diskette button and save it. And then I'm going to hit this button that says process and watch what happens. So off or out comes all of that, and you see the contours get drawn. The 3D lines get drawn. It's like we did before. Now I could have, let's go back to set my layers, grade name for suffix. Let's see what those are set as. Road underscore breakdown. Okay, road underscore breakdown. So now from here, okay, so road underscore breakdown. Breakdown. There we go. Now, so do this again. There we go. I want to be sure to get those colors back in there, just so you can see them. And it does the same thing that other thing that the other system did, the other process road networks. Okay, but let's say we have a situation like this. I'm just going to draw a 2D polyline. I'm going to go from here over here into here. I'm going to just leave it at that. And now, while I'm still in this road network, I'm going to choose my add a road. And I'm going to screen pick a polyline. So I just pick that. It says no centerline file associated. Assign the centerline file to that polyline. And this one's going to be Pine Street. And it wants to know a design profile. Well, there's Pine Street. Okay, so there they are. I'm still using this design template because it was last there. We'll leave it there for now. And let's edit our center line. Well, let's fit a curve. We'll put a 375-foot curve in there and save. Exit. All right, so now there we've got a curve off of that one. And let's edit the profile. Well, now look what happens here. Because it is crossing a road. Remember in our setup, we had this line that said show, where did I have it? Show vertical lines for intersection. So watch when I track my crosshairs here and I get right there. You see what I'm looking at over here in the plan view. You see I'm crossing that pavement of that Maple Boulevard. It crosses the crown of that road and comes off to the other side. So that's where it intersects that roadway. And you see, without me putting any vertical curves in here at all, it knows where it has to cross and it puts that in as a minimum. Okay. Now, all of these little things, if you zoom in tight here, you can see that those are little itty bitty, 20-foot vertical curves. There's a 0-foot vertical curve because that's where it's crossing the other pavement. Now there's another transition curve, so it's gonna go down to transition, back down to, get me back down to the ground down here. So we can still add a PVI, say, in here of, say, 100 feet. Let's maybe make that 175. A little bit bigger, there we go. And maybe even over here, you might have come into a different one. It's a little lower grade, but as it comes up, it still holds that crossing. Okay. I'm gonna save, I'm gonna exit. And I'll say, okay, now here's the prompt. It says, hey, you've changed something. Do you want to process it? I'll say yes. Center line change, yes. So now, what have we created? I'll show you. All right, so it's finished processing. Let's take a look at that surface, which was Forest Hills merged. Right there it is. It took care of the, we got some controls we might need to do in there, but you see it's found that intersection, crossed over it. So let's go back to my, let's go to this intersection. I'm going to double click that so that I can edit that, and I want to, let's open up these radius values. And let's process that again, see if we can clean up some of that. Made the radius returns a bit bigger. And we're not trying to crunch quite so hard. All right, and we'll take a look at that now. All right, so a little bit smoother transition in there between those. It's still got a little issue over here that I could, try to track down. But here's what I was trying to indicate. So if I say I've just selected that crossing road, like crossing Maple or Pine Street rather. So I'm going to just simply select it. And let's just move it. Say from there over to here. Maybe put that curve in it. Now you see what it did? It says, hey, this changed. You want to process it? I'll say, yep, go ahead. And so it's going to go through that same process. And it's going to give me some significantly different results. And particularly if I look at my design profile, if I edit that, you see I've got I'm coming off up here, I go across here, but then I'm coming down because I'm held to getting right there, so I'm going through this huge little fill valley. I can now oops. Can now make a little bit better transitions and then maybe put another one up here. And then maybe edit. Yep, that'll work. Okay, yep, process. So you notice what it did though, and the reason it made those really severe cuts through there is that it knew it had to hold that crossing intersection because my other road didn't change with it. So that keeps you from having, making changes to one and forgetting to make a change to the other. All right, so now I've got that. Let's take a look at what it looks like. And there it is. Okay, so you can imagine if you're doing all of that individually and building the surface out of Maple Boulevard and building the surface out of Pine Street and going back and having to track down that you've, built a crossing intersection, yes or no. By the way, if you turn those off, that's how those surfaces are built. Is it drops those design templates down and creates triangles, where it drops it down. You can see along the curved faces and along the, right in there's, for instance, a little raised point right there. But I think if it were me, I would take out, except yeah, I lost track of where I was now. I zoomed in too far. So anyway, it doesn't matter. I'm going to save that part. But anyway, it tracks all of that stuff, and then you can save that, exit, and go on, and you can build all of this stuff. Keep all of that stuff in this network file and just load it up every time you get to do it. Now, let's go back to, say, my Maple Boulevard and my design template series, and let's edit that design template. And I'll show you what the subgrades look like real quick because we're running out of time. If we exit that and choose a different file. Let me find a different file. So I've got all of these other files. None of them have subgrades yet. So I'm going to change from the folder that I'm in. I'm going to go to my Carlson projects. Folder, there's one. Yeah, there we go. So I'm going to choose my design template series. I'm going to pull this down and choose Carlson projects, and you should see demo template. Do you guys see that? Let me know, make sure that you have it.
I don't think that I do.
Okay.
But that's okay.
All right. Yeah, that's just step through that. I'll say okay to that and edit it to see what it looks like. So right now I basically just have, I've got an edge of pavement. It's a 10-foot road. I'm gonna change that to be say a 15-foot. Still says EP, that's good. I've got curbs. I don't. So that's just shoulders. Now down here, my asphalt, I need to make my asphalt instead of 10 feet, it's gonna go out to wherever EP is. And my stone is also going to go to EP. And then I'm going to add one more with this subgrade button. I'm going to go, what do I have? I've got 2-inch, 6-inch, so it's 8. I'm going to go another, so I'm going to say 16 inches from the top. And I'm going to go to EP plus 2. I'm going to call that sub base. Number 57. And I'm going to make it do a wraparound height of, say, 8 inches. Let's see what that's going to look like. Now, not quite exactly what I meant. Match the surface. AP plus 2. See what that looks like straight up. Okay, I need to go a little bit more. EP plus 3. Let's just go a foot past. Wrap around of 8 inches. Wow, really? Surely it's not that. So plus 3 wrap around. Well, let's just put it to straight up. So that'll be another bit of stone. And so let's save that, exit that. And now we've got some subgrade under that one. I'll say, okay, no, I'm not going to change it yet because I'm going to Pine Street. And I'm going to change that template to add some subgrade. Again, I'll just make this one the same asphalt. It goes out to the edge of pavement and it's going to be 2 inches. 2 inches, not feet, 2 inches. Thank you. And let's make that continued slope. Let's add another one. Again, continued slope, and it's going to be 8 inches. We'll call that in stone. A distance of 2 feet. Wow, really? Come on. Oh, I see, yeah, I was underneath it, all right, so. Let's make that a wrap around, wrap height of, say, 6 inches, and it goes to EP plus 3. There we go, that's what I was looking to do last time, all right. So now I've got asphalt stone and asphalt stone and a big sub base under the other. And so as long as I've named those the same thing, I'm gonna let it process, and you're gonna see what's gonna happen. The Pine Street had, I guess they both have curbs, but if we had a sidewalk or something, or we have a ditch on the one and not the other. So you would see how it's going to transition in between these different areas. So there's where our ditch is coming up here, and it's going to stop as it goes into that transition, but my edge of pavement line is going to run around and continue. So when I look at my combined surface, as you go through that intersection, you can see one of these, I thought I had sidewalks on it. But you can't, but you can see the, one road is slightly wider than the other. I don't guess it's enough to notice it. But anyway, it generates, all of this information, and we can see on our profiles menu, put profile, for instance, by surface. I'm going to look at my roadway compared as a reference to the original ground. And there, it's just like looking at cross sections, the way I've done that. I can adjust. And you can see it here in real time. As I go to move that, now there I'm going across at an angle, so it's going to look a little weird. All right, so sort of getting a drink from the fire hydrant or to try to get all of that information together, but it's generating these 3-dimensional lines that you can do. You can just leave them as 3D lines, and you can manually make surfaces from those, or these specialized tools like road network and process road design will create those surfaces for you, as well as other tools on surface menu like design pad. Let's just do a quick example of that one. Let's go over here on the side, and I'm going to just draw a rectangle. All right. And I see I'm somewhere about 135, 140, 140-ish across there. So if I go to surface and say design pad template, and I say target is surface file, I'm going to use ratios. I'm going to go to the outside because it's the pad that I'm designing. And I'm going to only check these bottom 2 on the left and the bottom 1 on the right. I'm going to set my spacings and my deltas at 10 and 10. Leave my shrink and swell factors of 1. Not worry about any subgrade depths. And here's now a layer I'm going to call pad, and I'm going to say okay. I'll pick that pad polyline. It wants to know the surface target. which was that phase 6 original ground. And I'm gonna go with say 3-to-1 side slopes. And it looks at that, it comes down here on the command line and says the range of existing elevations goes from 117.85 to 155. What do you want to make your elevation? Well, let's make it just 141. So there it is. It's going to be in fill down here because they're blue. It's going to cut up this way because it's red. And it said, you want to adjust the parameters and redesign the pad? I'm going to say no for them. Okay, so all I've done with that command is just draw, is to simply draw. Sorry, let me get these finally the right button. So all I've done is just draw some 3D lines. Okay. But I'm going to turn that into a surface. And I would do that by choosing to isolate my pad layer. And so now I've got a perimeter and I've got this data. So if I triangulate and contour, I'll write the file. I'll select it and I'm going to call it pad. I will use the inclusion areas because it's already generated for me. Erase any previous contours. I'll turn that stuff off at the moment. I'll not draw the contours. And I'll select the inclusion, no exclusions, select the data. Boom, there it is. Here's the pad. And you can see it, and as you drag the light source around, you can sort of see about it. You can add these other surfaces for reference. So you can see that's what it looks like. One on top of the other. You can see up here's where it's cut, but it hasn't merged it yet. Remember, we're going to do that with the triangulation file utilities. So by using that command, and I'm going to now restore my layers with view, restore layers. So I'm using these tools to help me design that pad. It has a target. It goes out and finds the existing ground. It knows how it ties into that existing grade. But simply double click that pad and it brings it up into an editor called Edit Pad Design Parameters. I'll exit that and I'll show you on Surface. It is this edit pad template, in which case it asks you to go out and pick it. So it shows you where it is. Here's what I had started with: 3-to-1 side slopes, an elevation of 141. Now it says no volume, so I'm going to say process, and it will show you the volume. I've got 5,600 yards of cut, 24,000 yards. I'm sorry, but 24,000 yards to fill, 5,600 yards of cut. I look at my reports and I can see, here they happen to be. And to make it balance, I would have to bring in 18,800 yards of material to make that part balance. But I can simply choose the balance button. And when that happens, I tell it, what do you want to balance to? Do you want to match cut and fill, or maybe you're designing a borrow pit and you need to take away 20,000 yards of material? You would set it up like this. And so it would change it until it has made that work. Let's see what it looks like. So 20,000 yards of material. So now you see up here in my volumes, I've got 27,000 yards of cut, 7,000 yards of fill. And here's those numbers. So 27,000 yards of cut, 7,000 yards of fill. So that's balanced in the sense that it met a particular number that I was looking for. So if I needed 20,000 yards of borrow material, right there's my design. And it's going to look like, this when I construct that. That's the amount of cut and fill I have to do. And when I do it that way, that material that I shave out of it here is going to be enough materials for me to use 20,000 yards on another part of my project. If, however, I did want it to be exactly 0 instead of, so you see how it resets itself. And now it's 14,000 yards of cut, 14,000 yards of fill. You can, move the pad. Let's say I'm going to go from there to over to here. And then I hit process. Off it goes again. And now I'm way out of balance. Again, I'll balance it. Say, okay. Now it rearranges. Notice the elevations are now set differently. And, I can just exit that. I can go back to isolate my pad layer, triangulate and contour to bring everything the same. Take my boundary, select my material. I've now got that as a surface. I'll go to my triangulation file utility here. I'll load in a tin file. Let's use the Forest Hills merged as the base surface. And I'll go next. And I'm going to merge a tin file. And I'm going to merge pad. And you should see it pop in. There it is. And now, down here where the output is, I'm going to just say save as, and I'm going to call this FH for Forest Hills dash pad dash merge. And save the file. I'll exit that. And if I look at that surface, I now have one contiguous uninterrupted surface that had all of those components made. Okay. So that's a little pad design. It automatically ties in the cuts and fills. Now I can do a couple of things with this pad. And it's at a particular, well, it has to be flat. So if I double click it and come back into this again, let's see, if I edit a vertex Z, so I'm going to give it a little bit of slope. So I'm going to choose that. It wants to know the vertex. I'll pick this corner. And right now it's 126.75. Let's put that down at say 124.85. And do the same thing here. And we'll put that one at say 125.6 on it. 125.65. All right, so we've done that. We'll process that. Okay, so we've changed a little bit here. It's no longer balanced and it doesn't really have a flat elevation anymore. So I'm going to exit that. I will isolate the pad, rebuild the surface, but I've changed it now. Inclusion, no exclusion. There it is. If I look at that surface, I'll turn on my contours. So every 2 feet, so there's my contours. And to get a color that's not quite,
Looking good, Ken.
there we go. All right. So now I've got a sloping top pad. I can use that as a target. I can now merge that in just like I've done before. I can draw contours across it. I go to my surface triangulation file utilities. I can do that whole business. Now, what I was telling you before about when you need to add 3D lines, or put these things at a particular elevation. Now, I would, if I go to, if I'm going to go to finish this as a set of design plans, I'm going to freeze a lot of this 3D lines, but I'm going to oh, by the way, I forgot to show you this under road network, and load everything back up here before I'll go ahead. I didn't mean to process that, so it's going to process again. I haven't made any changes. We'll just let it process. But what I meant to show you after we used those subgrids is we've got a report button. And part of that report, now this is huge because it shows you, I've got asphalt subgrade, stone, I've got subbase 57, concrete in my curb. You could have concrete in your, sidewalks. There's all kinds of different things here, and so it breaks it down by station to station. It gives you total cuts and fills, and then it runs through, all of those different subgrade points, and it accumulates all of this material so that when you get down to the end of all of that mess, you've got a grand total. And this is just the intersection bit down here. Okay, so and then that can all be exported out to spreadsheets. You can use that for your materials information. I meant to show you that. Sorry, I forgot. All right, so what we're going to do, let's say if we put an island on here, just like a curb around a parking island, it's going to be easiest, for me to, I'm going to do this by, say, drawing a rectangle here. And let's see if I remove these end pieces. And let's see what that distance is. Wow, it's quite an island. Yeah. Let me just get rid of that one. Let's offset. Let's make these an 8-foot island. All right, so there it is. And let's do something like this. And then we will connect these up. We will No, I'm gonna fill it those with 8-foot radii. Let's see if it will work. Sometimes it does. There it is. Okay. So now I'm going to join. There's a 2D polyline sitting there in space. Remember, we're sitting on a slanted pad that we're going to want to use to create this as a curb structure. So how do we put this right on the surface of that pad? And if you recall, like we did the pipes before, we look at our 3D data menu and we say 2D to 3D by surface model. We find our pad. We select the line we want to put on that elevation. We're not going to apply a vertical offset. You can keep the existing polylines if you want, doesn't matter. And we'll say add any grade breaks wherever it might cross a triangle. We'll say okay, and we're done. So now this is a 3-dimensional polyline that actually changes elevations. And it's exactly along that finished surface, even though remember it had I lowered this corner and this corner is higher, so it's got a little bit of cross diagonal slope to it. But we've now draped it right on the surface. And how do we build a curb out of that? Pete, this gets back to you were looking at how do I create these curbs? Well, this is my 8-foot island. I need to make that into a curb structure. So we've now elevated this. We've got it as a 3-dimensional line. And we need to put that in as a curbed island. So right now it's down on the asphalt pavement. Well, how do I bring it up to that 1/2 foot height? And remember yesterday we said no vertical faces. So I'm going to need to go to a tool, and it's actually just here on the edit menu where I'm going to use a 3D polyline utility. I'm going to offset that polyline. And I'm going to use this interval method. And so it's asking for a horizontal amount. So that's where I'm going to type 0.05, just 1/2. And the vertical amount, I'm going to type 0.5. So I'm going to select that one and which side to offset. I'm going to go to the inside. So I now, when I zoom in there, I've got that one. It is 1/2 foot taller, but just 0.05 further back. Now I'm going to repeat that command, 3D offset, same method. And this time I'm going to put the top of curb in, which would normally be 0.5 feet horizontally away, but I'm going to make it 0.4 so I can account for that little difference in the front. That'll be fine. And the vertical mount now is 0 because I'm level with the face of the curb, with the front of the curb. And I'm going to set that back there in the back. And now when I look at that structure, you should see the necessary 3D lines for that as a structure. And I'm going to now isolate my pad and whatever layer that was on. And I'm going to rebuild my pad surface. So I'll take my inclusions, no exclusions, grab my data. There it is. I'm going to view my pad. And so there now is your curb. So that contour line would come up there and hit the face and it would walk all the way up here. But the curb is, or the surface is sloping out from under it before it gets there. So it never gets across it. Now this gets up here and almost gets to the top, but doesn't quite, wraps around to the other side and comes out the other side. Now, if I change my contour intervals, I'll say every 1 foot. There you go. You got one that crosses up there. Okay. So, you know, that's how we add things on here. Just do it incrementally, do it in pieces. So that's it now. Maybe we have a maybe a drainage ditch. And we go, you know, we're going down that direction. And I just drew a 2D polyline. I'm going to offset that, let's say 5 feet. So now I've got the 2 edges of my ditch, but I need to create them on, so 2D to 3D by surface model on the pad. I'll now select those 2 things and I'm going to apply a vertical offset. I'm going to make them say -3 feet, so 3 feet in breadth. So they're now 3 feet below that pad. So they have some slope to them. If you can see, if I do a drawing inspector and then look at my polyline data, as I hover there, you see it's got a 0.75% slope. Right, so this other one has a 0.81%. Because it was all created on that surface as a target. And I can see that it was, well, it's now sitting there, but it's actually below the ground. Okay. Put it on the surface and dropped it below the ground 3 feet. Now, what do we have from here? Remember, like we created this pad in the first place, was this design pad template. We'll do the same thing, but this time, instead of it being a closed figure, we're just going to say, and I'm going to make sure I don't erase previous yet. So we're going to say, let's say call it pad dash. And my slope, I'll do a 1-to-1 side slope. So I'm going to pick the pad polyline. So this is the pad polyline. It's not really a pad, it's an edge. And then I'm going to target my original surface pad. And I'm going to go a 1-to-1. And I'm going to go to this direction. Okay. And I'll say no. And I'll do it again, do the same thing here. And I'll go 1, 1, and go this side. So now, you know, I can't, oops, I'll say no. So now what I've got is the makings of a ditch in my surface, because I originally landed on the ground and that's where it went down, but maybe I want it to go down, or maybe not quite so much. So if I erase that ditch, and let's say these are 3 feet below the ground, but maybe I'm gonna want these to be on the ground. So if I go to my 3D data menu, notice how much we've used that menu. And if I select that structure, so if I look at point number 13, first of all, I'm going to select all of these and uncheck this box so they're no longer locked. All right, so I've got this structure, and if I look at my first one up here, it has a certain elevation. It looks like that elevation stays pretty constant. So my cross slope across the top is not, it doesn't fall enough for us to see that. But if I want to change that elevation, I'm going to start this up here. I'm going to change the elevation. I'm going to pick the elevation from the surface for just that one point. So I'm going to lock that down, and I'm going to say, pick the elevation from the surface. There's pad. And so looks like it's already there. Okay. And I'm going to leave all of these in between, except for the last one. I'm going to lock down. I'm going to give it a slope instead of being flat. I'm going to say go at a -2%, just so it has some fall. I'll say okay, and I'll now get rid of this one, and I'm just going to do that 3D offset 3D polyline, same method interval. I'm going to go, let's say 4 feet across, no change in elevation, this to this. Okay. Now back to my pad, under surface, design pad template. Click here, pick that surface 1-to-1, 1-to-1, go in that direction. So you see it's on the ground up here, but it's into the ground down there. I'll say no. I'll try one more time here. I'm going to pick this one, go for pad 1-to-1 on this side, no as well. And if I make a little surface out of that, I could just call it ditch, or just do it all together. Let's just rebuild the total. It's my existing boundary, no exclusions, everything's in it. I now have this somewhat complex need to give it different color. You can see it a little better. There we go. All right, so now just with those few little tools of putting lines down and draping them on the ground, setting out, putting them on a surface and dropping them, or putting them on the surface here and offsetting them up and back. And in fact, we could even go one more to this one, and because that is flat across, if I have a so normally I would normally I would have taken the original 2D line work and gone to the midpoints and been all clever about it. All right, so I'm going to do the same thing with that one now. Finally, 2D to 3D by surface model. Go on the pad, selecting these. No vertical offsets, and say okay. So now I've got those all together now, and I'll verify that before I build the pad, making sure they're elevated. And they are. And now finally, because they're on that, I'm going to raise them up just enough so that when I then reform this surface, I'm going to have a crown on there instead of being flat across. So if I change the 3D data, change elevations by differential, I'm going to raise it up, say 0.33 feet. Okay, we lost Will, so that'll be fine because we're getting into some extra time. All right, so I will raise those two objects, and that's it. Let's just verify. And if I zoom this around here, yep, so it's got a little bit of height on it. And now I'll just go back and build that surface a final time. With my boundary, exclusions. Except one thing I wanted to make sure that I have on here to densify. Yes, let's go with that 10%. So yes, that, no, grab everything and off we go. And we look at that finally as a final surface, and you can see that now our island actually has the raised ridge line down the middle because we just simply drew the line, dropped it into place on the surface. And now you can see the edge of the curb comes up, goes flat across, comes up and has the crown across. Now it's probably, a little too high. It's 4 inches tall, but maybe not. I've seen worse. And you can see how this contour actually comes down and crosses there, and then it crosses across the top. We make that. Now I've got enough to get 2 showing because I changed my contour interval to 6 inches, which is a little nuts for this back here. But now you can see in the ditches, and there's actually maybe a little glitch in my ditch down here where I would consider adding a brake line. I gotta see where my timers are right now. Add a brake line, say from here to here, which it says it can't do. For whatever reason. There. Good. All right, so that took rid of that, got rid of that little stray looking thing. Everything else looks good. We go back out here, we exit. We save our changes. Might as well call it the same thing, add, yep. And we could then, freeze off all of this design stuff and turn back on our design layers here. We could merge that pad surface into our existing grade. We can calculate, earthwork volumes, say from the simple looking at the phase 6 original as a base, looking at my pad as the final. No need to restrict it. I can do shrinking swells, tonnage, all of the different things. Let's just keep it simple, say okay, and there's now the difference. This is, if I'm going to build that pad, then I need 9,000 yards of cut, 7,200 yards of fill. We have a little bit more cut than fill. And remember, when we did that pad, we told it to balance it, so it was 0. Well, now I'm out of balance because I've done some other grading to it. So at this point, it would tell you now the average, I've got like 2,000 yards of additional material I have to haul away. So I would have to change that elevation on the average 0.654 feet to make it balanced. So if I'm carrying it away, I need to push it down. No, I'm sorry, raise it up 0.654 feet. Okay, so you can do a very simple thing by going into your triangulation file utilities and add and just raise that up to by that amount, and you can achieve your balance condition in that regard as well. Okay. Let's
You
sort
make it
of,
look easy, Ken.
pardon?
I says, you make it look easy.
Well, it's not necessarily, it's the fact that I've done this kind of stuff for 40 some years, and I've done it with a number of different programs. So let me recommend that when you get some time on your hands, I know nobody has any time, but if you should ever, then go back and look through this stuff and go through these exercises, because it steps you through. And if you have to go back to the original link and download the data sets over again, that's fine. But this will help you go through this, and in particular, these grading tools. And that talks about the, how to set these pads. Let's see. Yeah, here's a case of, just like that building pad. Now here's what this exercise worked you through. I had a pad here and I had a pad here for a driveway. Well, this pad needed to be cut. You see the red lines that come up and meet along that ridge line. And this driveway did the same thing, but it doesn't need to do that. That's just the way the math works out, that if it's in cut, which it technically is, it goes up at a slope, but it hits this other slope that's coming up from the parking lot. Well, really what you need to do is start at the corner of that edge and just go straight down to the corner of this edge. You don't need that little ridge in between there. But there's no way to do that by hitting the easy button. You have to do it like this, and then you go into the drawing just like this, and let me turn these things off. And you would sit there and you would change these elevations, select those. You would take that ridge line, you would select that ridge line maybe and throw it away. And then maybe you would draw 3D polylines and you would snap to that endpoint, snap to that endpoint, and then get rid of those that form that up and down. Okay. And it's just being aware of things like that. And you can't be aware of them if you're not looking at them in 3D. So that's why I want to make sure you guys got, some exposure to that part. So, but go back over that. This will show you that it talks about the 3D viewer every time we jump into it. Here's a place for the template. Okay, so anyway. Put it through those, paces, go through these exercises again, watch the videos. I'll send those out. With the video link, it'll be sometime, at least by the first part of the week. And so there'll be
What, the video?
Yeah, because it's got to process and get up to
Sure,
YouTube.
sure.
And so, but they'll be
Well, it was
there.
a great lecture, Ken, and I'm really glad that I attended. I really feel I got my money's worth.
Yeah, well,
And
yeah, and everybody will get their certificates for the PDHs. In fact, I'll throw an extra half hour on these because we ran over today.
Yeah.
yeah.
Hello, Ken.
Yes.
I don't want to take much of your time. I know you have to leave. Actually,
No.
absolutely great
that-
class.
That was
And,
last night that I had to leave. I've got some time tonight if you want to stay.